you can make it real.
And here we are with Mars Perseverance, 51 years later, getting ready to do the first ever Mars return mission.
Eventually, we can bring those samples back to Earth and determine for the very first time, did life exist on Mars?
In less than an hour, NASA's 300 million mile journey from America's shore to Jezero Crater on Mars will begin with the launch of this Atlas V rocket into space. And at the top of that rocket, with a beautiful sunrise and shrouded by that protective fairing, is the Perseverance rover headed to Mars, ready to ride a column of fire and smoke on its way to the red planet. What a beautiful morning here on the Space Coast. Welcome everyone. Behind us, the star of the show. This is a life-size mock-up of the Perseverance rover, which is just like the one we are launching to space. Hi everyone, I'm Daryl Nail.
And I'm Mujige Cooper. In the 50 minutes leading up to launch, we will show you how this mission will reach and search for ancient microscopic life on Mars and test new technologies critical to the ultimate goal, future human missions to Mars.
That's right, and we've got the rocket on the pad and it is ready to go. A beautiful day outside. We're L-47 minutes and counting until launch, and so far the countdown to Mars is on track. We've got great weather, the rocket's looking good, and it puts us on track for a launch at 7:50 a.m. Eastern Time, the beginning of a 2-hour window.
In today's coverage, we will hear Grammy Award winner Gregory Porter. We'll talk live with Derek Muller of the YouTube channel Veritasium, along with the aerospace engineers, scientists, and a NASA astronaut.
Oh, it's going to be a great show.
Yes.
I love it. I love it. And we have teams from coast to coast, folks, helping us count down to Mars. We will go live to the Atlas Space Flight Operations Center, just a few miles away from us.
And we'll go live to California, to the Jet Propulsion Laboratory, where the Mars 2020 mission team is standing by to communicate with Perseverance after it gets to space.
And of course, we are here to tell you what the Perseverance mission is all about. It's an exciting day for all of us here. So we want to walk you through what you will see next during the countdown and the rocket launch. So let's send it over to Joshua Santora and Mick Wiltman, who are with the ULA and Launch Services program teams. Gentlemen.
Hey, good morning, Daryl. I'm Joshua Santora, and I am here at Atlas Space Flight Operations Center, joined by Mick Wiltman from NASA's Launch Services program. Mick, you excited to go to Mars?
I am excited to go to Mars this morning, Josh. This is a great day. The sunrise out there looks awesome on this rocket, and ready for a great launch today. Thanks for having me on the show.
Man, happy to have you along, providing a ton of good context as we go through. Before we dive into the story of Perseverance, we want to give you a preview of what's ahead today in the countdown. Things really got going this morning just after midnight, actually, and Atlas V is just about ready to fly. In a few more minutes, we're going to get the final check of the weather, and that weather report should be coming back really positive. It's been great all morning. We have the terminal count ahead after that. We will be proceeding through the last few minutes of the countdown, and then the drama will be at its peak at launch. When the clock strikes 0, the engines ignite, and the spacecraft and rocket take flight. After successfully passing through max Q just shy of 2 minutes into flight, the solid rocket boosters will be expended and will be jettisoned. Nearly 2 more minutes, and the payload fairing, what you might call the nose cone of the rocket that has been protecting Perseverance, will no longer be needed. It will split in 2 halves and fall away from the accelerating vehicle. 1 minute later, the Atlas booster will have finished its task of lifting Perseverance above Earth's atmosphere and being on the way to orbit. It too will separate, exposing the Centaur RL-10 upper stage engine that will almost immediately begin its first burn that lasts approximately 7 minutes. After coasting for more than 30 minutes, the second burn, lasting around 8 minutes, will take Perseverance out of Earth orbit and into solar orbit on its way to Mars. That sets up spacecraft separation and the final milestone we're hoping to hear this morning, the acquisition of signal. And I say hoping to intentionally because it's quite possible that Perseverance will be in perfect condition, but we won't make contact during the broadcast. So lots more to come, lots ahead. But Daryl, we're going to throw it back over to you now to tell us more about this amazing mission.
All right, thank you, Joshua and Mick. We've got a lot of really smart people and talented people that we're going to be talking to today. But let's begin with a scientist who's coming up in just a bit. I want to talk a little bit about Mujige Cooper, who's here. She is a planetary protection lead for this mission. Thank you so much. You've been working on this for a while, Moo.
Yes, this has been 7 years in the making, and I'm so excited to share this moment with you and with those that are viewing today. I'm just ecstatic.
It's fantastic, and we're in a launch period. People probably want to know, why are we launching today? Why are we launching right now? We're in a period that only comes around once every 2 years.
Yeah.
Explain that.
The orbits of Earth and Mars are on the same side of the sun so that we can reach that destination with less fuel. So it's the best time. Short journey, less power.
We like that. And we're studying the climate, the geology, and searching for ancient life. But Moo, what kind of life are we talking about here?
Well, when we search, we're not going to find dinosaur fossils, right? We're likely,
No?
unfortunately, likely we're going to find it in the form of microscopic life.
We're hoping
Ancient
to.
life.
We're
Hoping.
Yeah, we don't know if it's there, right?
Yeah, don't know.
Okay, well, that's why we're going.
Yes.
All right, thank you very much, Moo. And back here on Earth, our friends at Twitter are celebrating Mars 2020 in a very special way we want to let you know about. Check this out. If you tap the like icon on any tweet containing the hashtag countdown to Mars, you'll see an animation brighten up your screen. You can check it out. Also, the like button itself has a special little animation that you can see. Oh, right there in the corner. See that? Did you see that one? The little sun and the rocket?
You should
went around
hit it there.
That's right. You just hit it and it goes.
Oh, there you go.
It will also work in any language from our partner countries, including Spanish, French, Norwegian, and Italian.
Wow, that is pretty incredible.
That's pretty neat.
Yeah. And despite the daunting challenges, NASA has a long history of missions to Mars, going all the way back to 1965 with the Mariner 4 spacecraft.
Yeah, we've covered a lot of ground on Mars since then. So let's head out to California and join JPL's Raquel Villanueva. Raquel, what can you share about our history of exploring Mars?
Well, Daryl, in the past, we explored the red planet with orbiters and landers, but it was the ability to move around Mars with rovers that truly helped unlock its secrets. Today, I'm joined by Perseverance Deputy Project Manager Jennifer Trosper. She has worked on every single Mars rover mission for the past 3 decades. Now, Jennifer, how does today's launch fit into the history of exploring Mars?
Well, we have always been interested in Mars because it's the thing that's most like Earth that we know of. And it's a little bit different today, and so understanding what happened to Mars will help us understand more about our solar system and also more about Earth. Now, as we said, Mars exploration started in 1965 with the Mariner spacecraft flying by Mars. And in 1975, we actually landed the Viking 1 lander on the surface of Mars. And then after that, we started sending orbiters with more sophisticated instruments. Those instruments would do global mapping. They'd find the minerals. They'd find the topography of Mars. They'd actually study the weather of Mars. But we found out that those orbiters needed partners. They needed partners to go down to the surface of Mars and explore like a geologist on Earth would, where he walks around and takes pictures and maybe she takes some measurements. That's what these rovers needed to do, and that's really what started the Mars rover program for us. Our very first rover we sent in 1997, it was a Sojourner rover. Sojourner weighed about 25 pounds and drove all of about 400 feet. But she really showed us what value a rover on Mars could have. And so then the Mars program started the Follow the Water theme to try to understand Mars better. And the first 2 rovers that were sent to Mars to follow the rover were Spirit and Opportunity. They landed on opposite sides of Mars in 2004, and they drove 30 miles combined. And they both found evidence that there had been water on Mars in the past. But we still weren't sure whether that water fostered an environment that was good for life. And so then we sent Curiosity in 2012. The Curiosity rover was big, it had a big robotic arm, it had a drill, it had a science lab in the front. And Curiosity was trying to understand the habitability of Mars. Could Mars have ever fostered life? Could life have ever grown on Mars? And within months of Curiosity landing on the surface, she actually found an ancient habitable environment on Mars. But we still don't know if life ever did form on Mars, and that's the goal of the Perseverance mission.
Wow. Thanks, Jennifer. And now that we understand how each rover mission helps shape the other, let's get to know Perseverance.
You know, Mars is the closest place that we can reach with robotic exploration that we think had a really good chance of having ancient life.
The Perseverance rover will land at a location called Jezero Crater. Jezero Crater is a very interesting place. It's a crater that once held a lake.
There are a lot of craters on the surface of Mars that could have once hosted ancient lakes, but not every crater that we think had a lake actually preserves evidence that that lake was there.
It had an inflow channel and it had an outflow channel. That means it was filled. The crater was filled with water.
In Jezero, we have probably one of the most beautifully preserved delta deposits on Mars in that crater.
The major goal of the Perseverance mission is to investigate astrobiology on Mars, and in particular, to address the question of whether life ever existed on Mars. The Perseverance rover starts with a design that's very similar to Curiosity, but we've added to it a whole new set of science instruments. And these science instruments were purposefully selected to help us in the search for biosignatures.
We're going to be taking microphones with us. For the first time, we're going to have that human sense on another planet.
Perseverance carries with her a grand experiment in spacefaring technology, a helicopter, the name of which is now Ingenuity.
One of the major upgrades that Perseverance has from Curiosity is that it's able to self-drive for a distance of up to 200 meters per day. As the rover is driving, it's literally building the map of the road it's driving on Mars.
Scientists for years have told us that to really unlock the secrets of Mars, we have to bring samples from Mars back to Earth.
So what Mars 2020 is going to do is to drill samples, put them in small tubes. We're going to seal it in its own individual tube. We set them on the surface to provide a target for the second two missions, which hopefully will get in development in the next several years and could potentially get the samples back to Earth by 2031.
Perseverance is a very, very profound first step in both our understanding of our place in the universe and a stepping stone towards human exploration on Mars.
And a great breakdown of the rover there. Welcome back to the Kennedy Space Center in Florida, where our next Mars rover will be propelled into space by an Atlas V rocket. And the man who leads the company tasked with safely getting Perseverance off this planet is Tory Bruno. He is the CEO and president of United Launch Alliance. We appreciate you being here, Tory, this morning.
Oh, happy to be here.
How is the launch team doing? How are you doing?
Well, the launch team is doing great. They've been on station for hours. They're calm, they're confident, they're going through the script. I'm a little nervous, but I always get nervous before all of my 400 launches so far.
Wow. You get a little nervous. Why do you get nervous?
Well, you know, a rocket is such an incredibly powerful and complex machine. Everything has to go right. Nothing can go wrong. And it's just, it never gets old. It's always the same.
It's always exciting.
Yes.
And this is a particularly exciting mission. Talk a little bit about that. This is the largest and heaviest rover that we've ever sent to the red planet. So how did you configure your rocket to do this launch effectively?
Yeah, this is our second most powerful Atlas, the 541. We call it the Dominator. It's got 4 giant SRBs, each putting out 350,000 pounds of thrust to augment the center core. And so it has got the power to get out there to Mars, as well as the precision. It's the most accurate rocket in the world, because when we let it go, it's got about 200 million miles to travel on that transfer orbit.
And precision is key.
That is right, yes. So the power source for the Mars rover is a contained radioactive battery. I've seen it up close, and we had to alter the way we behaved around that.
Yes.
How has that changed your team's efforts?
Oh yes, the operations around that are completely different. Now, we have a lot of experience with these. We've flown all of America's RTGs, and we're the only provider that is certified to handle them. But, you know, it is still 11 pounds of plutonium, as you saw.
Yeah.
And in this particular case, the one very special thing was to install it in the VIF, where we would normally never breach the containment around the spacecraft, because it has to be clean and biological free. Right. But we created a portable clean room and brought this nuclear battery out and installed it in the machine while keeping everything perfect.
Awesome. Can you explain what the VIF is, actually, before I let that go?
Yeah, the VIF is the Vertical Integration Facility. So these rockets are so gigantic, we build them in a factory, but we can't assemble them there. Atlas and Perseverance are standing 20 stories proud right now on the pad. So they come to Canaveral in pieces on our rocket ship, and then we assemble them in the Vertical Integration Facility. And normally the last thing would be to bring an encapsulated, under the fairing, perfectly clean and prepared spacecraft and put it on top, which we did, but then we opened it to install the MMRTG battery.
Now that came late in the process, and that was intentional.
Yes.
You mentioned there's a certification for who certifies the rocket?
So NASA certifies the rocket, and then NASA and the Department of Energy certify a provider like us to handle a nuclear payload because of all these special requirements.
Very good. You know, when you were preparing for this mission, you couldn't have imagined, a year ago that you would have a coronavirus pandemic wreaking havoc on this state. How did you handle that, and how did you overcome it?
Yes, well, the one big lesson learned here is you can't buy back time. So when this broke out, our response was early, it was aggressive, and fortunately it was effective. So we did all the things you might be familiar with. We wipe down every surface every hour, we deep clean every evening, we are wearing PPE, we have our teams spread out, we actually change the flow of the work to keep our people safe, but to also keep these vitally important missions going. And of course, I can't say enough about our team. They're so disciplined and so courageous to persevere through all of this, and now to make our third launch under all of these mitigations. I'm just so proud of them.
Well, Tori Bruno, CEO of United Launch Alliance, we appreciate you being here, sharing your knowledge with us. Good luck with the rocket launch today, and enjoy it.
Thank you very much. Go Atlas, go Perseverance.
All right.
The countdown to Mars is well underway. Let's go to our launch commentator team for an update on the pre-launch efforts and a weather forecast. Joshua?
Hey, thanks, Moo. Operations this morning have been really pretty quiet. Mick, can you tell us what's transpired to get the rocket to the point that it is today, right at this moment?
Yeah, actually, Josh, it's great to have a quiet countdown this morning. That means really good things for us here in the ASOC. But the teams did come on station today about midnight. They got on station, started configuring the launch vehicle, getting it ready for fueling, as we've been listening to them fuel the first stage Atlas with LOX and the second stage Centaur upper stage with cryogenics. The team continues to do that. They've checked out the avionics, the electrical systems. They've also done a flight termination system check with the range. So all systems are looking nominal, and the team is now currently in their T-4 and holding, and just assessing the telemetry and the launch vehicle as we get ready to lift off this morning.
Yeah, and it is a programmed hold, so this is part of the plan. This is not anything going wrong. We do have a 2-hour window today, but everything is charging ahead towards that 7:50 a.m. Eastern liftoff time. We want to introduce you to a few of the teams involved this morning. We want to start with the U.S. Space Force. They're responsible for the range operations and weather activities. So, Mick, tell me about the range really fast before we get this weather briefing in just a few seconds.
Yes, the United States Space Force is responsible for public and personnel safety here at Cape Canaveral Air Force Station and Kennedy Space Center, where we're launching from. So a very important part of the mission today. They are one of 5 teams that are working with us to launch Mars Perseverance on its way this morning. And an important part of that, not only public safety, but is they also do weather for us to make sure that everything looks good. As we saw that sunrise this morning come up right behind, everything is looking good. So.
RC, LC, that one. RC? Conduct weather briefing on Channel 8 Weather Conference.
Roger.
Sorry, we thought we were going to get that for you live, and apparently the audio is on another channel. Forgive us.
We should be looking at a visible satellite image. We have now mostly clear skies, a few clouds off to the east over the water. We were monitoring one cell on the radar 10 miles to our southeast, which has dissipated, so things are looking great for launch. We are go on all LCCs and expected to remain go through the count. Our temperature is currently 80 degrees. Could climb to 82 by the end of the window. Winds are currently from 220, 8 knots sustained with peaks to 10 knots. 10% POV for the cumulus cloud roll. Proton flux is at normal background levels and expected to remain so through the count. This concludes the weather brief unless there are any questions.
All right, so I think we're in good shape. We heard a great report there. Again, hearing the go on all LCCs, launch.
Absolutely.
LCC.
Launch commit
criteria. I can never remember the second C. Appreciate that. So tell us about the T clock, because obviously we mentioned we're at T-minus 4 minutes and holding, so we have a difference here in these two clocks today.
Yeah, so the teams actually are working to two different clocks. The L clock, or what we call the launch time, or L-minus time, is the real-time clock, which continues to count down towards liftoff. T-time, that's the clock that the team uses for operational sequences of events in the procedure. This time has built-in holds in it, one of which we're in right now, 30-minute hold, which allows the team to adjust things that they need to do throughout the countdown tonight. So the L clock will continue counting down, and what's unique about this is at L-4 or T-4 as we pick up the count, these two clocks will sync up and we will count down to liftoff this morning.
One of the things we want to kind of piggyback off of the weather briefing for is to talk about the power source for Perseverance. Perseverance actually has a nuclear battery, which that might be a little bit alarming for people to hear that. It's not a nuclear reactor, it's a nuclear battery, and it's actually something that has been developed by the Department of Energy for this kind of a purpose. It's a multi-mission radioisotope thermoelectric generator, which is a mouthful, but it's an MMRTG. It's roughly the size of a 5-gallon bucket, and it is designed to actually make, how does this actually produce power for the robot?
So it's using nuclear material inside, right, to generate the electricity that's there. Starting off the mission today, it'll be about 110 watts of power that provides the spacecraft as we lift off. And it'll provide power for Mars Perseverance throughout its whole mission life. So that's the unique thing about this battery source that's pretty neat, is that it will continue for the whole time.
Yeah. The Atlas V has a perfect launch record, so it's in good shape. So we're not expecting any problems, but if there were a contingency today, we'd want you to stay with us to talk through some of the details, and we'd be providing advisories. We have teams that have been focused on this specifically, and they're working towards making sure that everybody is safe, and our robotic explorers are safe as well. So that's going to do it for now. A great weather briefing. We'll send it back over to you, to Daryl and Moo.
Thanks, Joshua. With the countdown to Mars well underway, we want to take a moment to honor our country with the singing of America the Beautiful.
We are proud to present to you now two-time Grammy Award-winning singer Gregory Porter. Lori Glaze, come on down.
Good morning.
For spacious skies, for amber waves of grain, for purple mountain majesty above the fruited plain. America, God shed His grace on thee and crown thy good in brotherhood from sea to shining sea. God shed His grace on thee and crown thy good with brotherhood from sea to shining sea.
The beautiful baritone voice of Grammy Award-winning singer Gregory Porter. That was outstanding.
It was so emotional.
If
really
I
great.
could launch the rocket right now after that, see some rockets, red glare, I say it's perfect. Thank you very much, Mr. Porter. We appreciate that. So, Perseverance will seek to unlock many mysteries about Mars, but remote scientific instruments can only go so far.
Joining us now to talk about returning Mars samples back to Earth is Dr. Lori Glaze, Director of NASA's Planetary Science Division. Thank you so much for joining us today.
It's my pleasure. Happy to be here.
Yeah. First, can you talk to us about the value of studying Mars samples here on Earth?
You bet. So one of the most exciting parts of this mission, of course, is that we're going to drill samples that we're going to go back to Mars and pick up and bring back to Earth. And part of the reason for that is, or the main reason is, that we can only go so far with the instruments that we have on the rover. They're wonderful, it's a great suite, but nothing compared to the state-of-the-art instruments in the laboratories around the world. So we really want to get those precious samples back here so that we can do that really in-depth analysis of the samples here. In addition to that, not only do we want to study them now, today, with those state-of-the-art instruments and facilities, we can preserve actually most of the sample for decades, and that will allow us to use future instruments that haven't even been invented yet, or answer questions we haven't even thought of yet. So it's really important to get those samples back here.
And could we confirm life if it is there with the instruments we have on the rover, or would that actually happen back on Earth?
I fully expect we won't be able to make that real determination until they're back here on Earth. We expect with the instruments we have on board to be able to detect biosignatures and the types of things that say, yes, this is a sample that may contain evidence of past life in the sample, but I think it would be very difficult to confirm that until we actually get the samples back here on Earth.
Speaking of getting them back here to Earth, the key part of this, how will you do that?
That's a great question. We're already starting work on that next mission called Mars Sample Return. We think it's going to launch. We're planning for a launch in 2026. This is a really complex mission. It's going to require 2 launches from Earth and 1 launch from Mars in order to get those samples back here.
Wow.
We're working really closely with the European Space Agency, our core partners on this mission. So we'll have a launch from the U.S., which will launch a sample return lander that will land on the surface carrying a fetch rover that will go out and pick up the samples, bring them back, load them into a rocket, the Mars Ascent Vehicle, and launch them into orbit around Mars. At the same time, when we launched from Earth, the Europeans are also launching an orbiter from Earth that will be in orbit around Mars, and it will capture those samples with that orbiter. We're going to capture them, and then it will make its return trip back to Earth, release them, and they'll come down and land in the Utah desert, where we will then safely carry them and put them in the curation facility.
Wow, what a process.
Awesome.
Yeah.
That is so amazing. Thank you so much, Lori, for joining us today. We appreciate your time.
pleasure.
Enjoy the launch. Get a view.
Go Perseverance, go Ingenuity.
Awesome.
Thank you, Lori. Well, in the early 1900s, the Wright brothers proved powered flight was possible on Earth. Now, NASA plans to test a powered flight on Mars with an ingenious helicopter. So, let's get back out to California now, and Raquel, the Martian atmosphere is 99% less dense than here on Earth, so this is no easy task to fly on Mars.
It is, Daryl. Now, hitching a ride on the Perseverance rover is an exciting technology demonstration. The Mars Ingenuity helicopter. Now, if successful, it would mark the first time humans have taken powered flight on another planet. Ingenuity's project manager, Mimi Ung, joins us now to talk about the set of milestones Ingenuity needs to hit in order to take flight on Mars.
Hi, by the way, we just had an earthquake in this room. But anyway, with that, Mars Helicopter Tech Demo is motivated by the potential of adding the aerial dimension to space exploration. In the future, a helicopter can serve as a scout for rovers and astronauts. A helicopter can get us to places of high scientific interest that cannot be reached today. It's not easy to build a rotorcraft for flight at Mars. The atmosphere there is very thin, about 1% compared to that at Earth. So a helicopter for Mars has to be very light and have a rotor system that can spin very fast. Behind me is the full-scale model of Mars Helicopter Ingenuity. It's very light, 1.8 kilograms, about 4 pounds. It's capable of flying through the thin atmosphere of Mars and is capable of surviving and operating autonomously. There is a set of milestones between now and Ingenuity's first flight. The very first one is when we turn on the helicopter and the base station to check their health. First time operating in true space environment. The next major milestone will be when Perseverance rover deploys Ingenuity helicopter to the surface. The deployment will also mark the first moment the helicopter starts to work on its own in a standalone manner. It will never return to the rover. And the first major milestone then will be the helicopter surviving the first cold Martian night, about minus 90 degrees Celsius. And we've designed the helicopter to keep itself warm. So we've planned for up to 5 flights in the 30 Martian days that have been set aside for our flight experiments. The flight data we get from the helicopter will inform our team the health of the helicopter and performance of each flight. The data could also include a few color photos. First ever photos of Martian terrain taken from aerial vantage. That would be true icing on our cake.
Cake, Mimi, thank you. And you're right, we did have a little bit of a shakeup, but everything seems to be okay right here so far. And we look forward to Ingenuity's first flight. And with that, let's head back to KSC as we continue the countdown to Mars.
All right, thank you, Raquel. When the name Perseverance was chosen for the rover, our country was in the early stages of the COVID-19 pandemic. Now, the name is also a fitting description of what NASA teams needed to get this rover to the pad on time. Joining us now is NASA Administrator Jim Bridenstine. Thank you very much for being here, Jim. Perseverance is meaning a lot, and that includes recently a 3.9 earthquake that we have reports of in California.
Yeah.
We just saw our own Mimi Ung. She said things were rattling there. So we are persevering a lot.
Good thing we're not launching from Vandenberg today.
You're absolutely right about that. Things looking good here in Florida. I want to ask you, why did you choose to move NASA forward on this launch in the midst of a global pandemic?
Oh, well, there's a number of reasons, but I think the biggest thing is, the public wants to see the United States of America and our international partners do stunning things. And we have a history of doing amazing things in the most challenging times, and this is no different. So look, here's the other challenging thing with Mars in general. We can only go to Mars once every 26 months when literally the planets are aligned. And if we miss this launch window, it would cost us $500 million to store this vehicle for the next 2 years. And so there's a lot of reasons to go forward. Some of it is, financial, the NASA budget, and then the other big reason is Americans want to see us continue to do big things. I want to be really clear though. We have made sure that all along this process, if somebody didn't feel comfortable working on this project, they had the option to not work on this project. And I will tell you, we didn't find that very often, if at all. Mm-hmm. I will also say that our highest priority was the safety of our people, and we wanted them to know that if they come to work, they're going to be safer at work than they would be if they stayed at home. And of course the personal protective equipment, the social distancing, the changing of schedules in order to minimize people working on the vehicle at one time. All of these things were put into place as protective measures. But it is true, the name Perseverance, which was given to this robot by Alex Mather, who's a 7th grader in Virginia. Mm-hmm. This is all about perseverance. And going to Mars, as you said, going to Mars is all about persevering in general. Doing it now is more persevering than ever before.
Real quick, we've got a launch, of course, counting down. How are you feeling?
Well, nervous as always. This is a lot of money at the top of a rocket, and of course not just the money, but the entire life's work of so many, thousands of people. So look, it's going to be a good day. We're knocking on wood. Right. But it's going to be a good day for NASA.
Thank you very much for being here, Jim. Appreciate
Always.
your leadership.
Thank you. You bet.
All right.
Thank you so much. We are now at L-14 minutes and counting. Let's check back in with Joshua and Mick to get an update on preparations to launch the rocket. Joshua, there's an important poll by the Launch Services Program happening soon, right?
Yes, absolutely. So the countdown is continuing. Obviously, a status report, we heard them talking about the earthquake, and everything is still good. We're hearing that on the back end that things are proceeding well. No no major issues or hiccups because of that. Everything going well. The savvy viewers out there will notice the clocks in motion, 2 clocks actually. The countdown clock there behind Daryl and Moo is at 4 minutes and holding, at T minus 4 minutes and holding. But the clock on your screen now is the L clock, and that is continuing to count down towards that 7:50 a.m. liftoff time.
Yeah, that's exactly right, Josh. As we talked earlier, the L time is the real-time clock that continues to count down to 0. At T minus 4 and counting, the 2 clocks, the T clock and the L clock, will sync up as the team continues to work their operational sequence events and the procedure. So the team is very focused this morning. As you already mentioned, the earthquake that was brought up, the team has assessed that and looked at it, and they're doing a great job and getting us to 0 this morning. So we mentioned the U.S. Space Force as one of the 5 teams earlier, and next up we have the NASA Launch Services Program team responsible for managing the launch, and we're going to hear a poll here from the NASA launch manager himself, Omar Baez. He's going to poll his team for their readiness to be able to report out in just a few minutes. So he's very punctual, so this should be coming right on time here in just a few seconds. Let's listen in now.
This is the NLM on the NLM net. Currently working, no issues on the range or the launch vehicle. Weather is green, 10% chance of violation, and winds aloft look good for the entire window. The spacecraft did experience some earthquake activity at their control center in Pasadena, but appears to be ready to proceed. And with that, I would like to poll the team for final launch poll and spacecraft configuration. NASA CE.
NASA CE is go.
SMA.
SMA is go.
SMD.
SMD is go.
NASA Mission Manager.
NASA Mission Manager is go.
LSP.
LSP is go.
Copy. NASA team is ready to proceed.
All right, so we heard NASA team is ready to proceed. He even mentioned the weather in there, which is great, only a 10% chance of violation. Again, a big thank you to Jessica Williams of the U.S. Space Force 45th Space Wing.
I like the fact that we're working no issues this morning into this count. That's an important part that Omar brought up. And the team, one thing you need to understand about the NLM is it's a combined NASA team of spacecraft and engineering. So hearing all those goes is good this morning.
Yep, and we're going to keep moving because we got a lot to do still. We're going to throw it back out to you, Daryl.
All right, thank you very much, Joshua. Our NASA teams across the country overcame challenges caused by the COVID-19 outbreak, as you've heard so far, to get this Mars rover to the launch pad on time.
We are about to hear from workers at centers in California and Florida who took every imaginable precaution while managing to get this vital work done.
When I saw the country shutting down, I thought for sure there is no way we're going to be able to continue this.
It's something that nobody expected. It's something that nobody could plan for.
Rather than your first priority being mission success and getting to the launch pad, your first priority immediately gets displaced, and it's now the safety of the people.
I was seriously thinking Mars would be Mars 2022.
It took a lot of work to put stuff together in order to keep momentum going, to keep people working safely, keep them healthy, and to keep the project on schedule.
There's no doubt that working in isolation, not virtual isolation, but in physical isolation from everyone else, is a challenge.
It's hard for me. I have 2 young kids. Sometimes I'm not able to focus or listen probably as well as I would want to.
A lot of our work was occurring in a clean room anyways, but that meant that even before we entered the clean room, we had to find ways of ensuring that we were not putting ourselves or others at risk.
Most of the time for these missions, our relation with the spacecraft customer is incredibly important. So usually we're able to be here working beside them on their equipment and making sure that all of their needs are covered even before they ask for it. It is a challenge, but we're used to meeting unique requirements here at the hangar, and we pride ourselves in our flexibility.
This is just another mission, just with a different set of obstacles that we have to overcome. It might not be, like a broken rocket, but it's it's got its own challenges.
Our job is to go into the unknown, and this is just another example of the unknown. How to make this job happen when you're doing it largely through a computer screen.
I asked the team a couple months ago if they would like to do something to kind of symbolize and mark these challenges that we faced, and they designed something that we called a COVID-19 perseverance plate that's now affixed to the port side of the rover. It has a globe representing all of us that face this challenge together, the spacecraft leaving the Earth on its way to Mars, and all of this supported by the now familiar staff and servant of the medical community. And we hope that this mission, in some small way, can inspire them in return. Pretty much everybody that I've talked to that's associated with the mission has said the same thing, which you could not have come up with a better name than Perseverance.
We have persevered through this. Nobody's given up. We will get this mission done. We will get it done through the pandemic.
I think it's a really important symbol of humanity, hopefully persevering through this great challenging time that we have right now.
We appreciate that team as well as the medical community that really stepped up and helped. And it's ironic, Moo, because the name Perseverance was chosen by a 7th grader who at the time he submitted that name, he didn't know that we would be faced with a global pandemic. So we are glad to have him and his family here along with the student who named the helicopter to watch the launch in person.
Their names are Alexander Mather and Vanessa Rupani, and they are watching from the 5th floor balcony of our engineering building, just a stone's throw away from the countdown clock. Look at that, there they are, looking cool. Alexander Mather, who goes to Lake Braddock Secondary School in Burke, Virginia, submitted the winning essay to name our rover Perseverance.
Yeah, they've got a great view. I've seen it from up there. They've got the VAB in the background, as you can see there, so
cool.
It's such a beautiful setup for this awesome launch. And Vanessa, who you can see her, and they're waving. Hey guys, appreciate you. She's a junior at Tuscaloosa County High School in Northport, Alabama. She entered the contest as well and came up with the name Ingenuity for our helicopter that will accompany our rover to Mars. Thank you both for being here. What a neat view that is.
Yes.
All right, folks, with the coast phase coming up, we want to let you know that after the launch, it will be about an hour before Mars Perseverance separates from the second stage. When that happens, the rover will then be on its way to Mars, so hang in there.
Yeah, don't go away, as we will walk you through the flight around the Earth, and we'll talk live with the astronaut Zena Cardman about our human exploration ambitions and NASA's Associate Administrator of Science, Dr. Thomas Zurbuchen.
It's going to be great, folks, so stick around. It's L-6 minutes and 26 seconds now. And time to focus our attention on the launch operation the rest of the way to liftoff. So let's send it back out to Mick Woltman and Joshua Santora. Gentlemen.
Thank you. I want to let you listen into the remainder of this poll in motion. Let's go to that now.
Range coordinator. Clear to proceed. Launch director.
LD is go, and you have permission to launch.
Proceeding with the count. ALC, verify T0 is set for 1150 Zulu.
So 11:50 Zulu. That is 7:50 a.m. Eastern time. So that time is correct.
As I'm watching Josh do the calculations on his finger there.
Get my abacus out.
That's right.
No. So there's a lot to come ahead. One of the things coming up in just a few seconds.
5 minutes, 30 seconds.
OS,
NSC.
Go, NSC.
Spacecraft on internal power and timer set for T0 of 1150 Zulu.
Roger. OS, start list data capture.
Roger.
Fantastic.
All steps are complete prior to terminal count. LC switch is ready.
Awesome. So things are really starting to pick up here. You're going to hear more and more chatter on those nets there. That call was to say that Perseverance is powered and ready to go, which is a phenomenal call.
Yeah, a couple things happened during that time, right? Launch conductor, ULA's launch conductor, Scott Barney, pulled the whole ULA team. They were all go. We got to hear
the third of our 5 teams.
The third of our 5 teams. We got to hear the end of that where the range was clear to proceed, and ULA's launch director, Bill Cullen, gave the authority to go for launch this morning at 7:50 a.m. Then we got to hear from the JPL spacecraft team that they are
the fourth team
that they are on internal power, and timers are set. They are targeting a liftoff of 7:50 a.m. this morning. So all things are looking good for us, Joshua, this morning. It's so, we talk about being nervous and excited. This is right here where we're nervous and excited.
Yes.
There are a lot of things happening as we get ready to count down to the liftoff this morning. We have about 15 seconds left in this hold before we pick up the count.
Yeah, we're going to listen into that. The fifth team, the one we haven't mentioned yet, is the Department of Energy, who is responsible for the MMRTG, the power source for Perseverance.
3, 2, 1, mark.
Awesome. So this is now the terminal countdown. This is that time when things become more and more automated over the next few minutes, and the energy's building, but the focus is increasing exponentially.
Yeah, as Tori said during his interview, you know, the teams are very disciplined, very focused on what they're doing, the operational sequence of events that they're following. They are making sure everything happens, especially in this T-4 and counting period, because there's a lot of things they have to do. They have to finish topping the vehicle, make sure that all the tanks, first stage, second stage on Centaur, are at flight pressures and full of fuel, ready to go for this morning. They have to make sure the FTS system is armed and ready for personnel safety just in case, so that the range can do that. They have to check the electrical and avionics systems. They have to make sure that the flight computer has all the information it needs to place Mars 2020 into the orbit it has to. So a lot of things going on. Exciting time for the team right now, but again, staying focused and following that procedure they've got.
3 minutes.
As we look ahead to post-liftoff, I want to kind of preview for you what's going to happen, because there's going to be a lot going on. You're not going to hear much from us. You'll actually be hearing from the ULA flight commentator, Jesse Gonzalez. He'll be kind of giving those calls past liftoff that will walk us through maximum dynamic pressure and into SRB separation, and then into fairing separation, booster separation, and then the first main engine ignition of the Centaur,
yes.
RL-10. And so then you'll kind of hear us jump back in and help provide some more context to what's going on. We encourage you to stay with us for the rest of the show, though. There's a ton more content we have to bring you, and we are far from over. I want to emphasize that the countdown to Mars is not done at 0 today. The countdown to Mars ends in February, when Mars 2020 safely delivers Perseverance and Ingenuity to the surface of the red planet. So we're going to let you listen in now and enjoy the last couple minutes of the process of launching a rocket.
One minute 59.
Vehicle internal.
1 minute 55.
Launch sequencer start.
1 minute 50.
Securing Centaur LH2.
Securing Centaur LO2.
So there we heard the fueling is
1
wrapping
minute
up.
40.
Yep, fueling is wrapping
Launch
up.
enabled.
Team is gone. Launch enable's
137.
done. Launch conductor sequence is ready to go. They're getting ready to turn the vehicle over to auto
FPS
sequence
armed.
at T-minus 31 seconds. So that's a big thing that they're getting done here. At T-minus 25 seconds, we will hear the team give their final goes that everything is ready and
1
the
minute
launch
20.
vehicle is ready to lift off and
OCU
perform
armed.
this mission.
SCS count started.
1 minute 15.
Produce ECS for launch. Roger.
1 minute 10.
Then valves locked.
One minute.
Rock, report range status.
Range green.
That's good to hear, Joshua, right
That means
there.
public safety there is accounted for, the FTS system. There you see on your screen a beautiful shot. The skies look great. There's little wind happening. You'd be able to see more of the venting. If there were wind, the trail of that venting. So we're ready to go.
And actually, that's an
40
important
seconds.
point. The reason we don't see that
Stable
venting
at
is the
F3.
vent valves have been locked up to put flight pressure into the tanks. And as we just heard, they're stable at step 3, which means the tanks are ready to go. And here at about 5 seconds, we will
28
hear
seconds.
the team
ECS reduced for launch.
give their
Roger.
final go.
25 seconds.
Status check. Go Atlas.
Go Centaur.
Go Mars 2020.
There we go. We are ready to go lift off this morning, Joshua.
Eight, 7, 6, 5, 4. Engine ignition. 2, 1, 0. Release and liftoff. As the countdown to Mars continues, the perseverance of humanity launching the next generation of robotic explorers to the red planet.
And Atlas TU has gone to closed loop control. Coming up on 30 seconds into flight, the RD-180 is throttling down as expected. Engine response looks good. And Mach 1, Atlas 5 is now supersonic. And passing 45 seconds into flight, vehicle is now passing through max Q, maximum dynamic pressure. And passing 1 minute into flight, the RD-180 is throttling back up as expected. Engine response looks good. At this time in flight, the SRB chamber pressures remain nominal. The RD-180 pump speed and fuel injector pressures are responding well to demands on the engine. Standing by for SRB burnout shortly. And we have burnout on all 4 SRBs. Burnout pressure signatures look good. Standing by for SRB jettison shortly. And we have a good indication of SRB jettison of all 4 SRBs. And the vehicle has gone to closed loop guidance. Vehicle body rates are responding nominally at this time. And coming up on 2.5 minutes into flight, the RD-180 is throttled down slightly as expected. Engine response continues to look good. At this time, the vehicle is 50 miles in altitude, 85 miles downrange, traveling at 6,000 miles per hour. And the Centaur reaction control system is now pressurizing to flight levels. And just past 3 minutes into flight, the RD-180 is now throttling to maintain a constant 2.5 G acceleration limit for payload fairing jettison. Engine response and vehicle acceleration look good. And we have good indication of payload fairing jettison and Centaur forward load reactor deck jettison. And the RD-180 is throttling back up to attain a 4.6 G acceleration. Engine response continues to look good. And Centaur has begun the boost phase chill down sequence to thermally condition the RL-10 for operation. Standing by for BECO shortly.
BECO's the call for booster engine.
And we have BECO, booster engine cutoff, standing by for stage separation. And we have good indication of Atlas Centaur separation.
So there you're seeing live footage.
And we have the Mach 1. RL-10 operating parameters look good. Chamber pressures are stable. This will be the first of 2 burns for today's mission. This first burn will be approximately 7 minutes in length.
So Mick, that's pretty exceptional footage there. That's live video. We will see that switch over shortly into an animation that kind of helps let us know what's happening with the rocket. But right there, a beautiful liftoff. Fun to feel that rumble in the building here as we proceed towards orbit and then towards Mars destination.
Yeah, absolutely. It was great watching an on-time liftoff of the Atlas V with that little over 2 million pounds of thrust. Cleared the tower in roughly 5 seconds. Josh, you and I worked the InSight mission, and if you recall, that mission on the West Coast took about 17 seconds to get past tower. So with those 4 solids today, this thing really got out of here and on its way. And it's, as we hear from Jesse, everything's looking nominal, and all vehicle parameters are within the design limits, and we're getting ready to come up on a main engine start for that first burn that Jesse was talking about.
Yeah, so recapping this countdown to Mars, the stations began to be filled up this morning just after midnight. Preparations, fuelings, powering up, all the way through that liftoff that happened, I think, Mick, it wasn't precisely on time. I think you said it was like 10 milliseconds early, so it's pretty much dead on.
Yeah, dead on. This team does a great job. As I said, they're very focused, very disciplined. As Tori also said, courageous. They have done a lot of work to get us to this point today through this pandemic, changed how they did some of their work, made adjustments as needed, a lot of cleaning, a lot of things, a lot of wearing their face masks, doing all kinds of things. And so this is an exciting time, not only for the JPL team in Mars 2020, but everybody that's worked this mission, and for the country and the agency. So this is exciting to see. We still have a long way to go, Joshua, before spacecraft separation.
Yeah, we had a really quiet countdown today, which is phenomenal, that we got off the ground on time. And we are proceeding now that we are in the middle of the first burn. It's tough to make out, but that engine is lit and it's firing. So we are in motion. There you go. There's that animation we talked about.
The telemetry there as we switch to a TDRS compatible data format.
TDRS.
Overall telemetry quality is very good.
The space tracking system. So there you go. This is not an actual video, but this is an animation that's driven by real data. So although we're not actually seeing the engine on screen right now, we can see that the engine is lit, and that is driven by the data that says that the engine is truly lit and we're in this burn.
Yeah, the launch vehicle continues to send telemetry to the launch team via the TDRS network, as you mentioned, and that allows them to continue to watch what's going on and make sure all their sequence of events meet their timeline. We continue on a nominal flight this morning. This first burn, as we heard earlier, will be about 6 minutes. This will get us into that park orbit around Earth, allow us to get on our way, and then get into that approximately 30-minute coast period that we're going to have.
8 minutes into flight, beginning to see the Centaur PU system balance out mass errors, seeing very stable body rates in the Centaur.
So we've mentioned 5 teams at play, and although if you were watching, hopefully you got a chance to see this in person, if not on camera, it's easy to kind of say, oh, it's over, like job done, but all 5 of these teams still very much engaged, still very much focused, because there's a lot of work ahead as we proceed through this first burn, and then a coast phase, like you mentioned, Mick, and then a second burn, and then spacecraft separation and the acquisition of signal from Mars 2020. So a lot more coming up here. Mick, I know for Launch Services Program, you guys manage the launch. So what does that mean? I mean, this is you guys' work in action right now.
By the way, that's the 5th team that we didn't get to mention. We talked about JPL, we talked about DOE, we talked about United States Space Force, and United Launch Alliance. LSP, we are like the brokers to select this launch vehicle and help with manage this mission. So we get our spacecraft customer, the JPL folks, they come to us. They have some certain requirements that they need for this mission. The Launch Services Program made up of engineers and flight analysis folks, and they look at everything, they help define those requirements, and then we go out and procure a vehicle from a commercial partner. In this case, it was the Atlas 541 for the Mars 2020 mission that was needed for performance, right? As you and I have talked over the last several days, Josh, one of the things that was important for us to look at was that performance, to be able to get Mars 2020 onto that transfer orbit into solar orbit to intercept Mars in 7 months. It's kind of analogous to a football game, right? With a quarterback trying to throw a pass downfield. You need a quarterback with a lot of performance who can get that ball down there where it needs to be, so the receiver can intercept that. In our case, 7 months later.
There you go. Yeah, it's the longest football pass ever. The Earth is the quarterback, the Atlas is the quarterback's arm, Perseverance is the football, and Mars is the receiver.
That's good, exactly right.
And what we also talked about is that technically, you could launch to Mars at any time if you had a rocket that was powerful enough. But this is the launch period every 26 months or so, as we've talked about, that makes the most sense because you require the least amount of energy to get to Mars, because it takes a lot to get there. Obviously, like the Atlas 541 is a workhorse.
Yeah, as Tori said, it's their Dominator. Right?
There you go.
I love that name for the Atlas 541. But we heard Jim Bridenstine, our NASA administrator, tell us that if we didn't make this launch period, we would be down for roughly 26 months.
It's
right?
tough.
So the period started July 17th and goes to August 15th. Today, July 30th, was one of those launch opportunities that we had. We had a 2-hour window, and within that window, we had several opportunities.
25, actually.
Yeah.
25 opportunities.
And we launched at the beginning of the window on our first opportunity to get Mars 2020 going on its way. And that, that sounds like a lot, and it is. The flight analysis group, both at JPL, LSP, and ULA, did a lot of work to pick out those target sets and figure out where we needed to be. So they've done a great job, and we'll see how this mission continues.
So, Mick, tell us about the 2 burns required here, and we're actually coming up on the end of the first one. Ultimately, a lot of people probably, and myself included at some point, just like, why wouldn't you just keep firing the engines? Just fire all the way through and get to Mars in one shot.
So the first burn gets us into that park orbit we talked about. We've lifted off, we've left Earth, we've got into a park orbit around Earth right now. And while we're in that park orbit, we will perform some maneuvers to kind of roll Mars Perseverance and the Centaur and coast during that time, basically setting itself up looking at the sun and away from the sun to control the thermal environments that are on Mars 2020 during this coast period. That coast period will allow us to coast around into the position that we need so that we can have that second firing to get the velocity needed to head off into Mars.
Yes, and we will be back for that second burn in just under 30 minutes now. But for now, there's more to learn about this mission and all the amazing science that's involved. Daryl, back to you.
All right. Thank you very much. Great launch and great job, guys. Back outside now to recap. An Atlas V rocket carrying Mars Perseverance rover launched on time from the Cape Canaveral Air Force Station at 7:50 a.m. Eastern Daylight Time.
Incredible. After the rocket took flight, it separated from the first stage and was then boosted into orbit by the Centaur's second stage. Perseverance is now preparing for a second burn that will put it on a trajectory toward Mars. That's just incredible to say. It gives me goosebumps.
It really is. And we're so excited about that as well. And while we wait for that second burn, hang in there with us because we got a lot of exciting coverage to go. We're going to welcome in one of our launch guests, Dr. Derek Muller. He is the creator and host of the popular science education channel on YouTube called Veritasium. He also holds a doctorate in physics education, so he's really smart. And that's why you saw us kind of having some fun, because Derek was here on set and we were just having a good time talking about this launch, which I got to start off with that. Derek, your first time seeing a launch in person, what'd you think?
I mean, what can you say? I have nothing to compare it to, but it was awesome, something I will never forget, and I definitely want to be invited back. So if you guys can make that happen, I mean, just so amazing to
You
see.
did a great job explaining physics. What did it feel like? Kind of walk me through as you were watching and experiencing it.
Well, it's like all the physics goes out the window a little bit. It's a very visceral moment between you and this very powerful craft. I think it's just amazing, all the engineering that goes into making something that's that powerful and yet that controlled. And to witness that is phenomenal. And then to feel the rumble of all that sound as it hits you, I found it an incredibly emotional experience. It's almost unbelievable to see it taking off. It's very surreal, that's for sure.
Nice. What excites you the most about the Perseverance rover?
Well, the Perseverance rover is going to do a lot of great science. So I'm excited, for example, that it's going to cache samples that we're going to bring back. Super excited that we're actually going to have samples from Mars in our hands. And I think that may clinch whether we can see that life is actually there. But I'm also super excited about Ingenuity, about the helicopter, which I got to visit out at JPL before it was strapped to the underbelly of the rover. And to think about flying a rotorcraft in, another world, essentially, in a place that only has 1/100th the Earth's atmosphere. It seems audacious, and I am impressed and amazed, and I can't wait to see if it works. I I'm cautiously optimistic. I think the team is phenomenal.
And you did, in fact, a YouTube story on it, a piece on your channel, and did a fantastic job going to JPL.
I did, yeah, and I was just so lucky that it was like there, you know, a meter or two away from me on the other side of a door in a clean room, and that was, yeah, one of the great moments of my life. Yeah,
that thing's going to Mars.
Exactly. Yeah, and it weighs like about as much as my laptop.
Yeah.
And you think about, you know, it's you know, substantial in its size, and it's going to go there and take off and fly all by itself, because of course we can't control it, given the time delay and everything. That is, I just think, one of the pinnacles of human engineering.
Yes, absolutely. Now, this is going to do some big science as well. What are your thoughts on the search for ancient microbial life on another planet, Mars?
Well, you know, I think chances are good that Mars once harbored life. It was so similar to Earth in the past. One can only expect, you know, life probably sprung up there as well. But I'm really excited for us to get that confirmation, because I think it really transforms our ideas about life and, you know, how frequent it is. Right now, all we have is this sample size of one Earth with life, you know? If we find another one, that's 100% more information and data, and I think it's likely that that life will not be exactly like ours. And I think it'll be fascinating, everything we can learn about, you know, other potential forms of life just by finding, you know, life on another planet.
You seem to suggest that you think there is life.
I do. I mean, you have liquid water for, I don't know how many, you know, 500 million or 1 billion years. On Earth, that was enough to create life. So, you know, the guess is that's not a unique thing, you know, right? I mean, the scientific hypothesis is you run that enough times, it's bound to lead to life again in other circumstances.
Dr. Derek Muller, we really appreciate you being here, YouTube creator with the channel Veritasium. We know you have a 2.5-week-old child your wife is holding out.
There are very few things that I could leave for, but this launch, that is one of them.
Thank you so much for doing so. Get a selfie with our full-size rover back here. You see that?
Please.
I definitely will.
Very good. Thank you so much.
There has been a lot of anticipation by NASA teams leading up to this launch, but some won't be able to fully celebrate until the rover has safely landed on Mars 7 months from now. Raquel, you're there with the Mars mission team at JPL in California. How are they reacting to seeing Mars 2020 take flight?
Well, Moo, it's been quite an eventful morning with the earthquake, but you could feel the energy building in the room in the run-up to launch. And now I'm with Bobby Braun, the Director for Planetary Science at JPL. Bobby, now that we've started our journey to Mars, can you tell me how you are feeling?
Wow, it's a great day. We're all so excited, and to get started in this way and to be on our way after all this work that the team has gone through. It's really just fantastic.
That's great. Now that Perseverance is off the launch pad, what are its next steps?
Yeah, well, we're almost on the path to Mars, if you will. The launch vehicle has done great so far. Our partners at ULA are just fantastic, and we're very happy to be working with them and for them to give us this boost so far. But we still have to have another burn of our upper stage. We have to pass through the night side, or the shadow of the Earth, come out on the other side and find the sun and power up, and then establish contact with the spacecraft. And once we do, we'll truly be on our way to Mars. We'll have a spacecraft that's power safe, that we can communicate with, and our journey will really begin.
We look forward to that. Thanks, Bobby. Now, Daryl, as Bobby mentioned, there's an excitement here in the room as the team looks ahead to the second Centaur burn. But before we get to that, let's learn more about the science on board this rover.
All right, thanks, Raquel. And as you mentioned, there are numerous scientific studies and technology demonstrations on Perseverance. Some of these are directly preparing us to one day send humans to Mars. One in particular is called MOXIE. Jeff Sheehy from the Science and Technology Mission Directorate is joining us now to explain, and he is here with us. Sometimes here at the
difficulty with his technology
that's all right.
here, Daryl.
Well, that's all right. It's a Britney Spears style mic, So
like this.
I don't know if that'll work fine. We can hear you. Yeah. Thanks for making the adjustment there. So Jeff, this is an incredible piece of technology here, this MOXIE, right? So tell us, what is it and why is it important?
Well, MOXIE stands for Mars Oxygen In Situ Resource Utilization Experiment. That's kind of a mouthful, so we grab a few letters out of there and just call it MOXIE. And I think the name MOXIE has a certain kind of attitude that's appropriate for this ambitious mission to Mars. But what in situ resource utilization is utilizing the resources that we find at a destination to produce useful commodities. And so what MOXIE's going to do is suck in the Mars atmosphere, which is mostly carbon dioxide, and produce pure oxygen. Oxygen is a commodity that we can use in our exploration endeavors, and so MOXIE is the first in situ resource utilization experiment on another planet.
How about that?
So that's why it's so important. If we can produce things we need at the destination, we don't have to load them in a launch vehicle, launch them from the surface to Earth, push them all the way to the destination, and land them on Mars or the Moon.
Saving incredible weight, fuel, resources to use them, the ones that are there and in place.
That's right. It took a lot of moxie. What were some of the biggest challenges in developing this technology, designing it, developing, building it?
Well, the team that produced the hardware that we just saw being launched on its way to Mars, they certainly had moxie because they had to overcome a lot of challenges along the way. When you start to develop new technologies, you're working in a laboratory and you've got all the room you need usually. And you can build it big and heavy because you're not trying to make it look pretty, you're just trying to make it work. And you've got all the power you need, and you can control the thermal environment, and you can have teams of people come in and tinker with it and fix it when it breaks and all of that. So, but, and you can probably see where I'm going with this, when you get to the point where it's time to fly that hardware to prove it out in the space environment or on the planetary surface, then the rubber really hits the road in terms of the engineering, and that's where the teams of engineers come into play, and they develop clever solutions to implement the process that's been developed in the lab and package it for space flight. So MOXIE faced a lot of challenges. You know what? Once you have to put it on the rover, the size becomes important. It has to fit in a certain volume on the rover. The amount of weight or the mass becomes really important. Every ounce you launch into space takes propellant to move it. So we want to make MOXIE as light as possible. Had to fit within a certain mass budget, or they would have kicked it off the rover.
Yeah, and we're glad you made it on the rover. And just real quick, and without getting too deep into the technical details, how does it convert carbon dioxide to oxygen?
So MOXIE uses a thermal and electrochemical process. There's a compressor that was built by a company called Air Squared. Some of that was funded under the NASA Small Business Innovative Research Program, actually. And they built the compressor. What it does is acquire the carbon dioxide from the Mars atmosphere and push it into the electrolysis system. A company called Ceramatech, a team led by a guy named Joe Hartvigsen. They're now called Oxyon Energy, I think. But they built the guts of MOXIE, which is the solid oxide electrolysis system that takes the carbon dioxide, CO2, actually pulls an atom of oxygen off the CO2, leaving CO.
Oh, wow.
And then those atoms migrate through the electrolysis system, and those oxygen ions are neutralized, and then they recombine. An O and an O becomes O2. And so we get pure oxygen out of the system.
That's fantastic. And so in order for you to get MOXIE on board the rover, actually you had to kind of clear through the very smart lady to my left. She's with Planetary Protection, so she actually had to clean off part of it. Right?
Yeah.
You had to heat it and then clean the
That's
O2
right.
sensor.
Yeah, the SOx part was actually self-sterilizing. It was hot enough so it cleaned itself. But there's a part, the O2 sensors, that needed vapor hydrogen peroxide sterilization. So it was the first time we used hydrogen peroxide on flight hardware.
Oh, that's awesome.
Yeah.
So you can say thank you.
Thank you.
Thank you. No, thank you.
Appreciate it very
Thanks
much.
for letting us do that.
Well, you know, in speaking about the rover, Moo, what is it? You know, Curiosity told us that we have, or had at one time on Mars, moving water.
That's
so,
right.
so what is Perseverance going to do in terms of confirming whether life could have been there?
Yeah, exactly. So the past missions set up the stage as far as understanding what could sustain life, and now we're actually looking for signatures of that life.
And so some of the answers that you're looking for, which one are you personally looking most forward to?
Yeah, I'm personally looking forward to seeing signs of life where no one will argue that it has a biotic source. It's very easy to say, oh, this chemistry could have happened from natural reasons, but I want to see a smoking gun. It would be awesome to see that.
Now, that's not exactly easy, right?
No, not at all.
And so explain that to us.
Yeah, so in order to get that definitive signal, one of the main things you have to do is make sure you have a clean instrument that you're sampling with. And so that's why we spent a lot of time cleaning, baking out hardware to such a high degree, 150 degrees Celsius for some of these parts, to make sure it was clean enough.
And so those parts have to be specially made to be able to handle that heat.
That's right, yeah.
In order to get it past you.
Yeah, all of the material selection, everything was done specifically for that purpose.
Where else in the universe, Moo, do you think we should explore for life?
Yeah, I'm really excited about Europa. Europa has an ocean underneath a thick layer of ice. It has vents underneath that have a heat source, so there's a source of energy for possible life.
Europa, a moon.
Yes, the moon. Yeah, icy moons. That's the next place to go.
It's interesting that you picked that. I mean, it's a very, very cold, cold place.
Yeah.
You've got a rover in front of you that is miniaturized.
Do.
We have one that is behind us.
Yeah.
Right? And as part of this, you also had to make sure that that nuclear battery was installed.
Exactly.
Yeah, there it is.
Yeah, this bit back here.
Tell me about how that worked, when you did it, and how that process was.
Yeah, it was only a few days before this launch day. I mean, we just finished counting our samples just a couple of days ago.
How about that?
Yeah, so we had to actually alter the way we sample. We take wipes and swabs of every surface of the rover. But for this, we had to make sure our head was far back and we had as minimal radiation impact as possible. But we got it. It was super clean. INL did a great job. Everyone has done a fantastic job making sure this was as clean as possible.
It's ready to go. What do you think about that full-size rover behind us?
It's incredible. It's like,
Yeah.
hey, you should be up there.
And apparently it is right to scale as you take a shot of it there. That's a beautiful rover. Well,
it is.
Thanks for describing all that to us, Moo. We
Yeah.
really appreciate the time
My pleasure.
for you describing that. All right, back into the show now we go. Moving forward, of course, this is the countdown as we go up. You can see the Centaur there in the graphics as we are tracking and continuing to track Mars 2020 on its way. And when searching for the possibility of life on Mars, it's all about location, location, location. And Perseverance's destination is a place called Jezero Crater. Let's go back out to JPL now. And Raquel, you've got a scientist there that believes Jezero Crater gives them the best chance of finding any evidence of past microscopic life.
That's right, Daryl. Knowing where to look for signs of ancient life on Mars can be a daunting task. It took 5 years to select a perfect landing site, and with us now is Katie Stack-Morgan, one of the project scientists who helped pick that location. Katie, can you tell us why we're heading to Jezero Crater?
Thanks, Raquel. There are many reasons why scientists are so excited to send Perseverance to Jezero Crater, and why we think that Jezero Crater is an ideal place to begin a Mars sample return campaign. At Jezero, we think that Perseverance can assemble a diverse set of samples that will help us resolve some of the most important questions about life beyond Earth and the evolution of planets over time. At Jezero, we know without a doubt that there was an ancient lake and river delta. And at Jezero, we have river valleys that flow into and out of the crater, and we know that that lake filled up with water and then overflowed. Life as we know it requires water to survive and thrive, and we think that Jezero has all the building blocks to support past life. At Jezero, we also have one of the best preserved deltas on the surface of Mars, and deltas in lake settings are ideal for supporting life. And the rocks that Perseverance will explore can tell us more about the possibility for past life on Mars. The rocks at Jezero Crater are also some of the oldest on Mars, between 3.5 and 4 billion years old, and that's the same interval of time when life was developing here on Earth. So by exploring the rocks in Jezero with Perseverance, we have the opportunity to explore more about the development of life in the solar system and can answer some of the major questions we have about that fundamental question. Back to you, Raquel.
Great. Thank you so much, Katie. And with that, let's head back to Kennedy Space Center. Daryl?
Much, Raquel. We are back here at the Kennedy Space Center with our most special guest, Moo, and the Perseverance rover. Here it is, a full-scale mock-up of the actual rover itself. Well, Moo, here it is.
Yes.
And so we've learned a lot about this rover so far. So tell me kind of describe from top to bottom what we're working here. At the top, you've got the mass cam, which is pretty tall, right?
It is very
it's
tall.
towering over your head. It is on a stage, but what does it do?
Yeah, so it has a lot of fun components. Some of them are the Mastcam Z. Z stands for zoom, so you see those two stereo cameras. And there's also that eyeball, what looks like an eye, is actually a laser. It shoots at the rocks.
A laser.
A laser, lasers. And then depending on the signature that comes back, the spectrometer reads it and tells you what the geology is.
And that's fantastic.
Yeah.
Some of the real exciting science, though, is happening right here on this part. This is the articulating arm that comes out, right, and then goes down onto the planet and starts drilling.
Exactly.
What all is here that's going to help us understand more about the geology of Mars, the climate, and whether or not there was life?
Yeah, there's of course Pixel and Sherlock, the really amazing instruments that are going to tell us about the biosignatures. But in the middle, there is the coring drill. The real drill will have a drill bit, a coring bit, which is hollow in the middle. And there's going to be a tube inside. This is just a 3D printed version. And as it's collecting samples, it's going to have samples that go directly into the tube.
Oh, you've got a tube there. Yeah,
so
show that on the camera
3D
there.
printed tube here. And it's going to go down the middle of the tube as it's acquiring the sample. Once it's done, it's going to dock with the bit carousel here. It's going to ingest the entire bit with the tube inside and the sample. It's going to rotate down to the belly, and there's going to be a little arm on the inside called the SHA, the sample handling arm, to manipulate it, take pictures, assess the volume, and then seal it.
That's fantastic. And so there's quite a bit of robotics happening between this part, the bit carousel, and getting it underneath. As we know, it's now underneath. But here's a special guest, and we're going to duck down. This is the Mars helicopter.
Yes, Ingenuity.
This thing is going to be actually tucked up underneath the rover. It was a late addition to this project, but it's probably one of the neatest things on it.
It is pretty amazing. 2,400 RPM that these blades are going to spin in counter directions.
Yeah.
It's a little bit under 4 pounds. It's super light. And yeah, it's going to be the first rotorcraft flight on the surface of Mars. It's spectacular.
And you know what's amazing? It will be taking pictures as well, right?
That's
Look at the blades.
Wow.
These blades turn, right? And they turn in opposite directions.
They
I
do.
understand.
They do.
It will have a camera on it. It will shoot live or shoot video.
Yes.
That we will then get back. It'll shoot video of the rover as it's doing its work, right?
Yeah, it's spectacular. And look at the clearance. I mean, this rover needs to clear this helicopter after it's deployed.
All right. Well, thank you so much for giving us the tour of the mock-up. It's just like the real one, except for it's not going to Mars. Well, thank you so much. And so by now you may have heard that this Perseverance rover was named by a 7th grader. And it was given that name, which is very special to us. And so we asked Hidden Figures actress Octavia Spencer to tell you why the Perseverance name is more than just a name to us here at NASA.
We are a species of explorers, believers.
We choose to go to the moon in this decade and do the other thing, not because they are easy, but because they are hard.
We are willing to do the hard things, to overcome the many challenges. This is what brings out the best in us.
We are go for a mission to the moon.
Our path has led to success and to bitter losses.
We come together today to mourn the loss of 7 brave Americans.
Yet, even when faced with tragedy and setbacks, we persevere. We keep striving. We keep believing. From space, we see our planet as a whole. We see the challenges facing it, and we face those challenges together. We will not give up. We challenge convention. We refuse to accept the status quo. The time at hand is hard, but we will persevere. We can still draw hope from the moon and the stars, from space, from exploration. There is a new day beyond the challenges we face now.
Curiosity, insight, spirit, opportunity. If you think about it, all of these names of past Mars rovers are qualities we possess as humans.
10, 9, we have ignition sequence start.
But if rovers are to be the qualities of us as a race, we missed the most important thing.
3, 2,
perseverance.
Launch commence. Liftoff. We have liftoff.
We are a species of explorers. We will meet many obstacles on our way to Mars. But as humans, will not give up. We will always persevere.
Our collective perseverance is what has gotten us to this day, and now Mars 2020 is on its 7-month journey to Mars with an anticipated landing date of Perseverance on February 18th, 2021. Now we are joined by Dr. Thomas Zurbuchen, Associate Administrator for Science at NASA. Dr. Z, thank you so much for coming over here.
God, I'm so glad I'm here, and I'm so relieved. You know, we have a space mission, and we're in touch with the spacecraft, you know, and everything is nominal. We're waiting, of course, for the second burn, but not quite there, but we're really close.
Yes. So can you tell us what makes going to Mars incredibly hard?
So there's really two pieces that make it hard. The first one is what we're doing today, which is you really need to head in the right direction.
Yeah.
So take it off the Earth and have a lot of energy and head exactly in the right direction, because what you want to make sure is in February, when Mars comes, you want to be right there so you can get captured. The second one, which is the one that's going to make us nervous in February, is to entry, descend, and land. You know, so the Mars atmosphere is almost the worst of all worlds. If it was really thick, you could do what we're doing on Earth, which is go in and with parachutes.
Yeah.
If there was none of them there, you could do, you know, what we do at the Moon. When in Mars, you have to do both on top of each other, which makes it 10 times harder than any of the other two, and so that's what makes it so hard.
Wow.
You've devoted much of your life to science, and I know you were asked the other day during a news conference, you know, why another rover, and you gave a pretty impassioned response. Why is this rover important in your mind to the work that so many people are doing in science?
So it's really kind of a key of a whole bunch of new research that we're doing that is focused on a question that for thousands of years philosophers have asked, scientists have asked, and we're ready to answer with the tools of science, which is the way to get reliable answers. And that is there life out there? We have, for 20 years, we've learned about the environment at Mars, and we're ready to ask that now. And the way we're doing it is with this rover. So it's really, for the first time in decades, the first astrobiology mission. We're ready for it. Where it's the next step, and of course there's others coming. You know, Dragonfly.
Yeah.
We're already thinking about, and you know, other missions. We want to, of course, go to Enceladus in Europa, you know, and really learn about life there also. So it's an amazing first in that respect.
And whether there's life there or not, that's going to be the answer that we're looking for in these places.
So yeah, exactly.
Yeah, and so we want to do a social media question real quick, if that's all right with you.
Oh, absolutely.
All right.
We have a question from Twitter. What is the key difference between previous NASA missions, rover missions, to Mars, like Spirit, Opportunity, Curiosity, and Perseverance rover? In what way is Perseverance unique from the previous ones?
So there's a fundamental difference in the approach. And the fundamental difference is that we decided to put the instruments on Perseverance, the best geology instruments on this, so we can find the right samples. And we decided not to put a chemistry lab on it. Guess why? We don't know which one yet. And so what we're doing is we're actually collecting the samples that we're going to bring to the best labs that are available to humanity, which are the labs all over the world.
Yes.
And that's the choice here. And that's, of course, to do that, we need to do another first, which is humanity's first round trip to another planet. And that's what makes it different.
We've got more with the launch operation to go, but real quick, how'd you feel about that launch?
Oh, I loved it. It's like punching a hole in the sky, right?
Yeah.
It's really getting off the cosmic shore, our Earth, into wading out there into the cosmic ocean. I just love it every time it gets me.
All right, very good. Dr. Thomas Zurbuchen, thank you for joining us. We appreciate you being here to explain all the science and the excitement that's coming up.
Thank you so much.
Appreciate it. Now we've talked to scientists and engineers, and we have shared highlights of the mission and tech demonstrations that are central to the Perseverance rover. And folks, we have a lot more to share.
Mars Perseverance has been flying in space for more than a half hour now. Let's check back in with Joshua and Mick to recap the flight so far and tell us what's coming up next.
Hey, thanks, Moo. Yeah, as you're seeing on screen there, that is, again, the animation of the Centaur in motion around Earth, in orbit around Earth. And you can see there, like I mentioned, the animation being driven by real telemetry data. Mick, how is the report coming back from the first burn and then currently our coast phase?
So we're hearing from Jesse Gonzalez and the engineering team is that everything so far has been nominal. Centaur's been performing well. All the settling firings have been going great, which is keeping the fuel that's still in the tank where it needs to be as we get ready to come up on main engine start 2 for that second burn, which is very important to get us our velocity and into that transfer orbit to Mars.
Yeah, so that will be up in just a few minutes, but I think we're going to actually send you back out to our main desk to hear. Oh, so sorry, I'm being held. We're going to hang out here. So coming up, so talk about C3, Mick. This is something that we talked about having to do with the energy to leave Earth and go somewhere else. We're talking about having to get to speeds over 25,000 miles per hour. That's Earth's escape velocity.
Yeah, so C3 is basically just the technical term that we use in the aerospace industry to refer to the velocity that we need to get the vehicle where it needs to be. So as you said, we got that little over 2 million pounds of thrust that we left Earth this morning with those mighty 4 solids on the Dominator. I still like that from Tori Bruno. Tori, I'm gonna take that one from Tori. But we got off here and into the park orbit with the proper velocity we needed. And then, of course, this second burn is so important for the velocity we need to get in transfer orbit.
Awesome. So the Dominator punching a hole in the sky, as Dr. Zurbuchen said. So we will send it back out now to the main desk and be back with you in just a minute to catch that second burn. Daryl?
All right. Thank you very much.
Thanks so much, Joshua. Joining us now to talk about how special these missions are is Dr. Michael Watkins. He's the director of the Jet Propulsion Laboratory in California, which planned Perseverance's mission to Mars. That is my home center. Thank you for joining us, Dr. Watkins. So, we have so many great questions for you. Why are missions to Mars unique?
Well, you know, I think they're unique for 2 ways. I mean, one is just Mars. You know, it's been in our imagination for centuries. You know, it's a place that looks like the Earth. It looks like it could be home to us. It looked like it was once home to to what could have been life. And the fact that we can get there, and we can get there every couple of years, and we can send missions, and we can build on those missions, and you can learn from your mistakes. You can learn from your successes. One of the things I like to joke about is, we say Perseverance looks like Curiosity, but the people who built them are the same. They look even more like each other. And so they, so a lot of our folks worked on Mars Pathfinder, they worked on Spirit, Opportunity, they worked on Curiosity, and now Perseverance. And that, that history, that group of folks, they're just world leaders, and it's why we're successful.
So you oversee the Jet Propulsion Laboratory in California and doing incredibly complex work. Why are these robotic missions so hard?
They're hard because you can't really see what's going on. You can't use your human responses, right? You're used to driving your car and you see what's happening, and you turn the wheel. In this case, we've got to tell the rover, we've got to prepare the rover to do a lot of that stuff on its own, right? And so we've got to understand Mars, we've got to understand how the rover works, and we've got to put all that together into a machine that can function more or less without us. Mm-hmm. So we talk to it once a day, and we say, how are you doing, and go over there and do these experiments, and then it's got to do that. So, we kind of give it its intention, mm-hmm. but then it's got to do all those activities by itself, and that's a challenge. And the further away from the Earth you get, the harder it is. So you get out to Saturn, you get to Europa, you get beyond, and it becomes harder and harder.
Yeah. Real quick, one question to wrap up. You've been in touch with the folks out at JPL. On air, there was an earthquake that played out. It was a 3.9 magnitude. How is everybody doing? How's your team?
They're doing great. Our view is it's just Pasadena. It's just the Earth being excited about going to Mars. So it was a very minor earthquake. We have them a lot in California.
Okay.
Maybe it's like hurricanes here or something, but it's tropical storms here. But it was a very minor event, and everything's fine. And we are on our way to Mars.
Okay. So a little rumble here in Florida, some rumble in California. It works out great. Mike Watkins, thank you so much. We appreciate you joining us on the broadcast.
My pleasure. Thank you.
All right.
Awesome. We will have that conversation, a conversation with Zena Cardman coming up, which I'm super excited about.
That's right.
Yeah. On the other side of the Centaur burn and spacecraft separation. We'll also highlight 6 major technologies that NASA's focusing on over the next decade, including the critical energy needs for such missions. But with that, let's turn our attention to the next operational steps. Joshua, are you there?
Yeah, Moo, we're here and we're excited. We have a fuel pre-start call just coming in. We are getting ready to hear the call for this second burn of that Centaur RL-10 engine. Again, Mick, explain what this second burn is for.
So as we talked earlier, the second burn is really to get us that velocity as we head into that transfer orbit, right? Centaur and Mars 2020 will head into that solar orbit on its way with the proper velocity. We will then get ready to separate Mars 2020 on its way. And I'm hearing that settling is done and
we have main
engine start.
There we go. Awesome. And again, that animation there being driven by actual telemetry data coming from that rocket. So that's a phenomenal sign. And again, I think that it's tough with these images. Perspective and scale are so important. This vehicle is in Earth orbit. It's not near anything, so you can't see the acceleration of what's happening right now. But for 8 minutes, it's going to be picking up speed.
Yeah, this is the burn that gets us really moving in the direction we need to go, that fast velocity that we need to get out of our park orbit and head on our way to Mars. Of course, Centaur and Mars 2020 are still together,
system is in
and
closed-loop
as
control
we're
as
hearing,
well.
everything is looking nominal on this fire so far. Main engine start was good, and the firing is going well, nominal, as we see in the animation there.
Fantastic. So this is rocket science, and it's not easy. We actually want to bring in now, we have a special guest. This is Dr. Denton Gibson, excuse me.
Yes.
He is a rocket scientist. His official title is Senior Vehicle Systems Engineer. Denton, how are you doing?
I'm doing well. Thanks for having me.
Yeah, did you enjoy that? Obviously, you got to kind of spectate. A lot of days, you guys sitting on console, you have to kind of focus on your computer, but you got to see this one today.
Oh, yes, and it was a beautiful launch today.
Yeah, nice sunrise. Hey, tell us about your role with LSP. I was not making up things when I said you're a rocket scientist, but what exactly do you do?
So as our role in LSP, as a vehicle system engineer, we are the engineering team lead for a lot of the rockets that we launch our science missions on. And we are responsible for the oversight and insight into these launch vehicles for the NASA.
That's awesome. And I know in the past you've supported a variety of vehicles. Tell us a little bit about the vehicles that you have supported and the ones you're focused on today.
Yeah, so some of the vehicles I supported in the past is the Delta II, which was a long-time workhorse for our science missions, as well as the Pegasus and Taurus/Minotaur C. And right now I've been focused mainly on the Falcon 9 and Falcon Heavy.
Yeah, awesome. So obviously not focused on the Atlas V, but a lot of that experience and the process is the same. I want to take a moment to pause and say Denton's there at Hangar AE. That's the NASA Launch Services Program's hangar. They're very proud of that. We call it the telemetry center of the universe. That's where the data for today is flowing. But I wanted to also ask you, is the process the same for all these vehicles? When we talk about the telemetry and these sort of processes of getting from Earth to Mars, does Falcon 9 experience translate to Atlas, or are they completely separate?
So the overall process for many of these launch vehicles are the same, whereas you ship stages to the launch site and assemble the launch vehicles by stages. So in that sense, they're the same, but there's a lot of differences between the launch vehicles that may change that process a little bit. But in general, the processes are the same.
Yeah, and Joshua, I was going to say, Denton, I worked with Denton quite a bit over the years, and he talks about the different vehicles he's worked on. But Denton is one of my senior vehicle engineers in LSP, and so although he's not totally supporting Atlas V today, he does have experience with Atlas V, and as he said, things are very similar. So using his experience, we're able to train and bring on new generation of engineers, and Denton's been a huge part of that to allow us to grow our bench, if you will, to start working commercial partners.
Yeah, awesome. So Denton, tell us a little bit about kind of what's involved, what goes in behind the scenes, what's the rocket science of going from Earth to Mars, this maneuver to go into solar orbit?
Yeah, so a lot of the things that happen behind the scenes it's a lot of analysis work done by our analysis teams. I mean, it's months and months of analyses that are performed based on the orbit insertion, the performance of the launch vehicle. A lot of modeling and simulations is done to be able to get to this point to where we can transfer from Earth orbit into solar orbit.
Awesome. And obviously you're a rocket scientist. That's for a lot of people, that's like the pinnacle. That's like, hey, I want to be a rocket scientist. So where do you go from here in your career? Because obviously, I'm sure there's lots of things that you'd like to go and accomplish.
So, going from here, I mean, one of the coolest things about this job of working in the launch services program is working the launch, right? I mean, who doesn't love a launch, and who doesn't love working launches?
Yeah, we love them. We love them. Excitement this morning, right, Denton? We got to see that's what it's all about.
Of course. So, one of the ideal jobs would be a launch director, because you get to work all the launches. I mean, how cool is that?
No, yeah, that's true. And I guess you get to, is it right to say you call the shots, or is it that the buck stops with you, or how would you say that?
I'd say the buck stops with the launch manager. As today we talked, right? Omar Baez is our launch manager for Mars 2020, and he had to poll the team and make sure everything's ready to go. So the buck does stop with him right there on today's launch. And as Denton says, I think there's a lot of people that would love that job, and Denton's definitely looking at that next step. So I guess we need to give Omar and his assistant launch manager, Tim Dunn, a heads up.
Yeah, there you go. Dr. Gibson.
Dr. Gibson is
Up
on
and
the
coming.
way. Yeah.
Awesome. Well, Dr. Gibson, before we let you go, give us a real quick snapshot. I know you have a mission coming up later this year. What are you working on?
So we're supporting the Crew 1 launch coming up. So we're helping commercial crew out with that one, as well as Sentinel-6 as far as the LSP missions that's coming up later on this year. And so we're excited about that one.
Yeah, a ton going on. Dr. Gibson, appreciate you. Thanks. And I want to take a special moment on the commercial crew note to comment. We've got a big day coming up.
Yes.
Pending weather. There's a tropical system that might kind of get in the mix here, but we have a tropical system that could create some problems. Otherwise, we've got Bob and Doug from Demo 2. They're coming home on August 2nd.
Yes, I was going to say, Joshua, that's important for us also in LSP. Denton was my lead VSE, along with a few others that are in the group that worked that mission with the commercial crew program, and so it's really important for us to be able to support other programs within the agency to make these things happen. As we launch Mars 2020 today, which is another step for us getting humans to Mars, right? Is getting humans launched off of Earth soil was a huge step for off of American soil.
Yes,
was a huge step for us.
Yeah, and so talk about that really briefly with LSP. Obviously, Denton there, appreciate him and his contribution, and you working towards commercial crew, but also supporting Artemis, which is also part of that path of getting humans to Mars someday. Artemis is about learning to live on the moon to sustain a presence there with the eyes on Mars. So how is LSP supporting even Artemis?
Yeah, one of the things there is the Gateway program, right? Deep Space Logistics that is working a lot of that. And so LSP is in the works of supporting Gateway and helping them work with the commercial partners that are providing the rockets for those kind of missions that are out there and future things. One of the cool things about working with the Launch Services Program is that we work with all of our commercial partners, SpaceX, United Launch Alliance, Northrop Grumman Space Systems, and of course some up-and-comings. You may have heard some, right?
It is a growing
Blue Origin.
field. Yeah.
It's definitely a growing field in the aerospace industry, and LSP takes pride in working with those commercial partners to figure out what we can do for NASA and the country.
Awesome. Yeah, it is an exciting time for spaceflight. The commercial spaceflight industry is booming. There's always new things happening. If you keep an eye on the news, you will see new things. We're getting word now that the engine cutoff here should be happening momentarily. Once we see that happen, we'll have roughly, I believe it's 5 minutes until we actually see the spacecraft separation occur. So we're going to stay with you through that, but want to kind of just preview that for you, that hopefully on screen here you should be seeing that engine cutoff, and that's completely expected. That's a nominal operation, as you say, Nick.
We'll hear from Jesse Gonzalez, who's looking at the launch vehicle telemetry and watching the animation there. So let's listen in for Jesse here.
And there's the call, and there's the animation, again, modified based on
The
data.
RL10 shutdown parameters
let's talk
look
about
good.
communication for a minute, Nick, because it is not an automatic thing to just shoot information at Earth and have that be usable. So how do we go about communicating not only through launch, but on the way to Mars, and then once we're at Mars?
Yeah, so the important thing this morning is when we lifted off from Complex 41 here at Cape Canaveral Air Force Station, we had ground stations that were looking at the launch vehicle and tracked it all the way to provide data. Once we got onto orbit after stage separation, you heard a call out for TDRS, the telemetry network that NASA owns, which, by the way, is also used for the ISS and will be used hopefully for the landing with Doug and them.
Yes.
So getting off the ground today was great because we could deconflict some of that TDRS usage, right? But TDRS is very important for us to be able to get the telemetry from the launch vehicle back down to Earth here. And then, of course, when Mars 2020 separates and it gets on its way to Mars, then the JPL team will take advantage of NASA's Deep Space Network, which has been around for a long time, to be able to transmit commands and data back and forth to the Mars 2020. So it takes a lot of folks to work those, and the TDRS TDRS and Deep Space Network are very important to not only the science missions, but human space flight also.
Yeah, and I think the coordination of that is something that people don't get a chance to understand much, because as you said, we're using TDRS for crew return, we use TDRS for space station, and TDRS is not an unlimited resource. We have a good number of TDRS satellites in orbit that help us do these things, but it is a coordinated effort across the globe, because we even have ground stations in Australia, I think.
Yeah.
Where are all of our ground stations even?
We have ground stations everywhere, not only here in America on the West Coast and East Coast, but then you get into South Africa area, Australia, you said. We have several ground stations that catch up different things for missions. But, of course, in orbit, TDRS and the Deep Space Network are very important. And as you said, there's not an unlimited amount of resources there in the TDRS network. So we have to coordinate those things within the NASA agency and with our commercial partners when they're used for our launches. And again, that's another part of what NASA does as an agency.
Yeah, so just on that note, kind of thinking about around the world, currently this spacecraft is roughly over the South Indian Ocean. So that's just thinking about how fast we're moving, just the amazing world of spaceflight. It's just hard to put into words sometimes of like, we're literally flying around the Earth and we're already halfway around it. And so I want to talk actually about planetary protection some more. I know we heard about that a little bit from Moo, about how they're working to protect Mars from contamination, so to speak, just putting things there we don't want. And we have to consider that, or ULA has to consider that when they're flying to Mars and delivering the spacecraft.
Yeah, it's a combined team. ULA, JPL, LSP had to look at that for when we get ready for spacecraft separation here in about a minute, right? One of the things we talked earlier is that Centaur and Mars 2020 are on the same path towards Mars right now. So once we separate, Centaur will do a CCAM maneuver, or what we call a contamination and control avoidance maneuver, and then blow down what's left of propellants in its tank. And by doing that, we have now put Centaur on a different track so that it will not intercept Mars or interfere with Mars 2020 at all for approximately the next 50 years.
Yeah.
And that took a lot of work by the JPL team and the launch team to make sure that would happen. So again, another planetary protection maneuver that had to be done.
Yeah, and I understand from the telemetry experts in LSP that this rocket actually, after the second burn, is not actually aimed straight at Mars for that reason. It's actually aimed slightly off of Mars. And so Perseverance, Mars 2020, will redirect itself just slightly. We're not talking about over 7 months. A little bit of difference here makes a lot of difference later.
Absolutely. And Josh, we heard Jesse telling us that Centaur is spinning up. This is the maneuver right prior to spacecraft separation, where we get into a slight roll to give Mars 2020 some
stable Centaur tank pressure,
stability.
Very good performance from the RCS system, and stable indications from the avionics systems as well.
So RCS there, the reaction control system, that's those small, the series of those small engines that you see firing around the spacecraft. Those are used for that in-flight operations that they need. The rolling activities, as Mick's saying, is basically providing stability to the flight of Mars 2020 as we go forward. Tell us about actually...
And we have successful separation of Mars 2020 with the Perseverance rover.
There we go.
Awesome. We got some nice applause there. That is a big moment. We are hoping to get some live video back from that because of the time delays with communicating with things in space. We don't have it at this instant. We're hoping we'll get to see that here in a few minutes, and we'll bring that to you if we do. But tell us about the separation maneuver, because the apparatus, the actual... It's a really simple design.
It's a separation clamp. We'll talk about that in a minute, but as you see on your screen right now, you see the Mission Director Center where Omar Baez and the team are. And Josh, you and I joked about this a little bit earlier, but with the pandemic and everything going on, the teams have done a great job. Normally, spacecraft separation.
2020 with the Perseverance rover, the Centaur will now perform its standard propellant blowdown sequence to inert the vehicle and complete today's flight after completing its CCAM avoidance maneuver. This will conclude today's commentary of the Mars 2020 mission. This is Atlas Flight Commentary signing off.
So that's the end of ULA's job for today.
Jesse Gonzalez did a great job with the ULA commentary this morning. But what I was saying about the Mission Director Center is normally we would see a lot of clapping, a lot of hoop hollering, a lot of high fives, handshaking.
Yeah.
But with the pandemic and everything, people are staying their distance, taking the guidelines seriously, wearing masks with this. So we saw a lot of air high fives, right?
Yes,
and stuff.
absolutely.
So that does not take away from what the team is, how excited they are. They have done a lot of work to get to this point, and that seeing spacecraft separation is awesome. So,
yeah.
but
well,
getting,
and throw all on top of all that, 2020 was like, here, have an earthquake,
right?
So it's just we did it. Like
yes.
we're most of the way there, not there yet.
Yeah, as you heard Omar earlier in the broadcast say, a lot of us when we started this, when the pandemic started, we kind of thought Mars 2020 might be Mars 2022.
Yeah.
But Mr. Bridenstine and the NASA agency decided to move forward. The teams found ways to do this. As we heard, they were disciplined, they were focused, they were courageous. And all that played off today with a successful launch at 750 and now spacecraft separation, Mars 2020, Perseverance and Ingenuity on their way to the red planet.
Hey, we're going to wait for acquisition of signals. Stay with us, but really fast, Mick, tell us very, very quickly about this mechanism, because we teased it.
We teased it, yeah.
How do these things separate?
So the separation system is called a Marmon clamp band, actually designed earlier by Karl Marx, one of the Marx brothers. Very simple design, but it has some spring systems in it that once the signal is sent and the bolts release the clamp band, the springs basically just give just enough force to push the spacecraft off the front of the vehicle.
Awesome. And again, hopefully we'll see that video here momentarily. But for now, we're going to send it back to you and check in for one final time in a little bit with the folks here at ASOC. But Daryl, back to you.
All right, thank you, and great job, both of you, Joshua and Mick. It's always great to see Mick explain that springs are what's getting us to Mars. All right, so we've got our second burn underway. We've been flying for right about an hour. And as you just saw, spacecraft separation went well, and so that's fantastic. We can now say that Perseverance is officially on its way to Mars.
What a beautiful thought that is. And while NASA has been tracking the spacecraft since launch with its tracking and data relay satellite system, I know the mission control team at JPL is turning their attention to the next milestone, and that is ensuring that the array of communication antennas known as the Deep Space Network, or DSN, begin to receive a signal from the spacecraft flying the Perseverance rover to Mars. We expect to see the teams acquire the signal close to 9:14 Eastern Time. Though, as you saw, the spacecraft separation has occurred in the shadow of the Earth and out of line of sight of the system, so this could take a bit longer than estimated.
All right, and so finding life on Mars won't be as easy as you might think, and we talked a little bit about that. Here to talk about that and more is NASA astronaut Zena Cardman. Zena is here to join us, and we're so glad that you're here. Thanks for taking the time. First of all, your reaction to that launch.
Wow. Every time it takes my breath away. I had actually never seen a launch before until I got this job as an astronaut, and now I'm very lucky to have seen 3. And every single time, it just makes me feel so much emotion.
And kind of talk us through, I mean, it got up quick, right? So as you were watching it, you feel the rumble?
It did, yeah. First you see it go up, and then you feel the rumble as the sound travels to you, and you can really feel it in your chest. It's amazing.
Very good, very good. Talking about astrobiology now, you have an amazing background. You've searched for signs of life in some of the most extreme environments on Earth, the Antarctic, the Arctic. So you're used to looking for these biosignatures. What are your thoughts about this rover searching for signs of life?
Yeah, you know, we have a lot of experience looking for signs of life in unusual environments here on Earth. So if you take a look at Mars today, it's very cold and very dry, and we have some places on Earth that are actually a lot like that. So places like Antarctica or deserts. But if you want to look for signs of ancient life, life that existed billions of years ago perhaps, when Mars looked maybe a lot more like Earth does today, you have to know what those signs of life left behind in the rock record. Because microorganisms are very tiny and very soft, so they don't leave a fossil the same way a dinosaur would leave a bone or a footprint. So instead we use these chemical signatures.
Daryl's dreams shattered again. We told him there's going to be no dinosaur bones on there. He really wanted them.
Something wiggling around, but no.
So why do we need to go to the moon before we go to Mars?
That's such a good question, because we've been to the moon, right? But we haven't been to the moon to stay. We really don't know how to live off of Earth on another planetary body, and we really need to figure out how to use resources, use tools, especially if we want to do geology on Mars. The tools that we use here on Earth are going to look pretty similar, but they might not work quite the same way. And because the round trip to Mars is so much longer than the round trip to the moon, when we go, we want to do it right.
Very good. And how do you like that rover behind you? Huh?
Oh my gosh, I love it.
Yeah, it's great. Hey, I want to ask you some social questions now. These
Absolutely.
are some from our audience who have been watching.
Oh,
so
great.
We appreciate you doing that. Our first question comes to us through Facebook. Thomas asks, will Perseverance land to investigate the landing site for a future manned mission in the same location?
Yeah, you know, that's a really good question. I think one of the most interesting things about doing a mission to Mars is choosing where you're going to go.
Yeah.
Because, you know, you can imagine planning a mission from Mars to the Earth, and if something landed in Utah versus landed in the ocean, your vision of Earth might be quite different. So one possible approach is taking a human mission and going back to somewhere where these rovers have been already, or maybe we'll decide to explore somewhere new. I have no idea yet, but I can't wait to find out.
Awesome. It looks like we have another social media question from Twitter, from Huda. Do you think that in a few years we'll be able to send astronauts to Mars in a safe way if we are able to send a rover like Perseverance to Mars in a safe and amazingly planned way?
I hope so. We won't go until it's safe for humans for sure, and we're not going until it's a round trip. But actually part of this mission, of course, is a round trip, and so we will eventually learn how to send a rocket to Mars and then have something lift off of Mars and come back.
Well, Zena Cardman, thank you so much for being here. You did a fantastic job. You were a great guest, and
Thank
glad
you so
you enjoyed
much.
the launch.
Oh my goodness, it's impossible not to.
No doubt. All right, thank you.
both.
Now, as you can imagine, there are a lot of systems to develop and prove out as we prepare for sending humans to Mars, as you just heard. Here now are 6 technology disciplines that are critical to the success of our future explorations. NASA's first Mars rover were powered by solar energy, but dust storms caused issues by blocking much-needed sunlight. So NASA upgraded to nuclear batteries provided by the Department of Energy. And joining us now is the Assistant Secretary for the Office of Nuclear Energy, Dr. Rita Barnwell. Thank you so much for being here.
Great. Thank you for having me.
First
Excited
of all,
to be here.
how did you enjoy the launch?
It was amazing. Absolutely amazing. So fortunate to be able to be here and be invited to watch it. I'm just giddy.
Had you ever seen one before?
No, I hadn't. It was my first one.
And what'd you feel as you were?
It was, you could literally feel the launch. So it was very exciting.
Very good.
Yeah.
So it's really interesting. When I saw this segment, I was just fascinated by the whole nuclear part of this. This is right in your wheelhouse. So explain to me, how did the Department of Energy get into the business of making nuclear batteries for space exploration?
So space exploration requires power sources for the long-lived missions that we need for this type of activity, for heat and electricity to be provided to the spacecraft and the scientific instruments. And nuclear energy can certainly provide that power. One source is the radioisotope power system, RPS. Part of that RPS is the radioisotope thermoelectric generator, and RTG. I know that's a lot of acronyms, but you got a decoder ring, so I hope you're good there. A space nuclear power system that converts heat into electricity without any moving parts. RPSs work by converting heat from the natural decay of radioisotope materials into electricity, and that's what we have up on the rover that just got launched this morning.
Yeah.
It consists of two major elements: a heat source that contains a radioisotope fuel, mostly plutonium-238, and solid-state thermocouples that convert the plutonium's decay heat energy to electricity. DOE developed several generations of nuclear space power systems that can be used to supply electricity and use the excess heat for a variety of other space applications. This one that was launched is called the Multi-Mission RTG, and it was designed with the flexibility to be able to be operated on planetary bodies with atmospheres just like Mars, as well as in the vacuum of space.
It's amazing the longevity of that battery.
Yeah, I heard it could last up to 14 years.
Right.
Will it actually last longer than that duration?
It can, and actually right now it was 17 years, 3 years here, and then 14 years out in the mission itself. So we're very excited about that. That's one of the benefits of powering this mission with nuclear energy. The RPSs that are currently powering Voyager 1 and 2 that are exploring the extremes of our solar system also are being powered by an RPS that has lasted for 43 years. Wow. And
That's
so
a long time.
That's a great extent of time.
Yeah.
The MMRTG is essentially, it's a nuclear battery, like you said, and it contains only 10.6 pounds of plutonium dioxide fuel, and it provides 2,000 watts of thermal power. It's similar, the material that's used in this is similar to what was used in the two Viking spacecraft that landed on Mars in 1976.
Wow.
So this technology has been around a long time, and it's well proven.
Yes.
Dr. Rita Baranwal, we thank you very much, the Secretary, or Assistant Secretary for the Office of Nuclear Energy. Thanks for coming out. We're so glad you enjoyed the launch, too.
Thank you for having me.
You're welcome. All right, here's a statistic you might not know about. Missions to Mars, roughly half of them actually make it there. Imagine that. But right now, we know the health of the Mars 2020 rocket is good because it's sending back a stream of data to our telemetry nerve center here at the Cape. Let's go back now to Joshua Santora to learn more about that. Joshua?
Yeah, thanks, Daryl. So we talked to Dr. Denton Gibson, who is one of the guys that works behind the scenes, but there is a group of folks that work behind the people behind the scenes, and Jessica Connor is one of those. She's coming to us now from the same Hangar AE location. Jessica, thanks for joining us.
Hey, it's a pleasure to be here. Thanks so much for having me on.
Yeah, so tell us about what you do to help make all of these activities, and as Daryl mentioned, the telemetry happen. What do you do for, what's your role for LSP?
So I work as a mission communications engineer for LSP. That means that I'm getting the video, data, and voice requirements from the spacecraft and then ensuring that they're able to go ahead and perform these operations once they actually get to pad phase.
Joshua, I was just going to say, Jessica's one of our wizards. You said behind the scene within the Launch Services Program as engineers, we depend on our folks at AE to make sure that we get everything we need to do our assessments as engineers. So they make everything possible there.
Yeah, absolutely. So Jessica, tell us a little bit about how you get the data back and then how it's utilized out to the team.
So while it's on the pad, we go ahead and get that data through the umbilical lines, and then that goes ahead and goes back to the engineers, and they're able to provide fleet insight based on the data that they get from the consoles.
And can you tell us about how long you've been working this mission? People probably don't understand how much time goes in ahead of time behind the scenes to make these missions happen.
So I've been working for about 2.5 years on this mission. About 2 years out, we start working with JPL to go ahead and get those requirements. And then we've been working with them since to go ahead and get processing video and also being able to talk back to JPL, being able to talk to headquarters and stuff like that.
Awesome. And so what's been the biggest challenge for this mission? I know that this mission's presented a lot of unique challenges for all of our teams, but for you, where has that challenge lied?
So we have a ton of experience from different mission comm engineers from the past. And so the most unique thing about this mission has been our treatment of COVID. And it's amazing what we've done to go ahead and keep the control room safe for all of the people on console and to go ahead and launch this mission on time and successfully.
Hey, listen, and we did it. We have the data coming back,
Yeah.
so that means that I think that means you did your job really well today.
I would say they did their job great, Joshua. They found new ways, as we talked earlier with the launch team, finding new ways to do their stuff. The folks out at Hangar AE also found new ways to make sure that all the engineering team could perform their fleet's insight assessments and support today's launch. So that team out there has done a great job. They actually make us in engineering look good. So we appreciate all the work you guys do, Jessica.
Yeah, awesome. Jessica, congratulations. Job well done. Thank you for joining us for this interview today.
Thanks.
All right, so Mick, things are pretty quiet now, and that's expected because we're just hanging out for the signal acquisition. The time there is the estimate based on the pre-launch data.
Yes.
Right now, we're actually in the shade of the Earth, so we're behind the Earth, and so we'll come out of that at some point shortly, and then hopefully acquire that signal because there's some solar rays that have to play in here. So still kind of some. I don't know if tense is the right word, but we're anxious still.
Yeah, I would say we're anxious. We're focused still. As I like to refer back to what Tori said earlier, right? Focused and disciplined. Even though it's pretty quiet right now, we have had spacecraft separation, which was a huge milestone for the team, an exciting time for us at NASA, ULA, JPL, the DOE, and our United States Space Force family. But the team is still sitting on console. They're still following their procedures. They're still performing everything that needs to be done as we await the acquisition signal. Some of the things that are going on here behind us is ground securing and everything here at the complex to make sure we can safely enter and do the work. So
yeah,
a lot of work still going on.
Yes, and we're going to send you back to Daryl because we need to check in and talk to the folks who are going to be getting that data back. So Daryl will check in for one last thing in just a few minutes.
All right, thank you very much.
And you can imagine driving out into the countryside and you're farthest from the nearest cell phone tower, and you look down at your cell phone, you see one bar, a very faint signal. And as you mentioned, Mars is very far away, so you get a very faint signal, very much less than 1 bar. And so thankfully, we have on the ground from our Deep Space Network managed out of JPL, very large antenna dishes that can detect that very faint signal. You're talking about a signal that's basically like an incandescent light bulb, and receiving that from millions of miles. We have 70-meter antennas and 34-meter antennas. A 70-meter antenna is about the size, to give some context, about the size of a 20-story building. So very large systems that can detect that very faint signal.
Great. And the Deep Space Network also communicates with all of our other missions beyond the moon. Now, how far have we gone into space?
Well, our Voyager missions are the farthest and fastest human-made objects that exist. Voyager 1 is nearly 14 billion miles away from Earth. It takes almost 20 hours one way to communicate to it. So once again, you can think about that light bulb. Could you imagine turning on a light bulb or a light switch and that light taking 20 hours to get to your eyes? And so basically, to communicate to Voyager, we send a command saying hi. It takes 20 hours to get there, and every 20 hours to receive a response from Voyager. So very far away. Thankfully, Mars is not as far away, as you mentioned, several million miles, not billions. So it takes not 20 hours, but it takes about 7 minutes. So it's a little better situation there.
Wow. So what does it take to add the Perseverance mission to the Deep Space Network?
Well, it's a lot of pre-work before the launch. We test with the launch vehicle. We test with the spacecraft. We test with the rover. We test over and over again to ensure that when it launches, when the spacecraft separates, when it lands on Mars, that we can have confidence that it will be able to establish that communication with us back on Earth. That's very important, and we instill that confidence by testing and making sure we have a lot of testing up front. And the payoff comes when we see those great awe-inspiring images from Mars. And so a lot of testing happens up front, and a great team that works on that.
Great. Now, getting an acquisition of signal is a very significant moment. Can you tell us how it works and what we should expect to see for this mission?
Yes, that's a very important moment. And sometimes you'll see a spectrum graph that's a couple squiggly lines on the bottom, and what you expect to see is a peak in the middle come up, and that's what you call the carrier signal. And the carrier signal is described as a carrier because what it does, it brings in the signal. It carries the signal to us. Therefore, we can see that signal and know that we're receiving data. And basically, we see the carrier signal, but after that, we have to decode what the signal's saying. And hopefully what we're seeing is that the spacecraft is saying, hey, I'm doing okay. I'm on my way to Mars, and I'll see you there in 7 months. And so we expect to see that signal, and then we'll decode it and be able to get the health and safety of the spacecraft. But also what we'll also look out for is how to track it. So once we have the signal, we'll lock onto it. We'll move our very large antenna dishes, and as the Earth spins, we'll track the spacecraft around the globe. This is a global effort. We have our station in Canberra, Australia, and Madrid, Spain, and Goldstone, California, who will all be part of this tracking as the spacecraft goes to Mars. So very exciting time, and we're looking forward to hearing from Perseverance shortly.
Great. Thank you, Philip. Now, we are just a couple minutes away from the first opportunity we will have to see if the Perseverance signal on the Deep Space Network is up on our screens. That moment brings us one step closer to Mars, but we have many other milestones to hit over the next 7 months, and I'm with Perseverance's Chief Engineer, Adam Steltzner, who will tell us what's in store for the rover. Adam, what should we expect to see next?
Well, Raquel, we are... After we acquire signal, we have left the building. We are on our way to Mars. We're no longer in orbit around Earth. And what will happen next is we will start our cruise phase. It'll be about 7 months before we make it to the Red Planet. We have a set of planned trajectory change maneuvers that we do during cruise to adjust our targeting. In fact, we're targeting to miss Mars right now. We're on the way, general direction of Mars, but in order to make our Atlas Centaur, which threw us in the direction of Mars, not run into Mars, we're on a missing trajectory, and we'll do TCM-1, which will target our impact with the Martian surface in a few days. So we start to monitor the spacecraft, make sure it's healthy and happy, and tweak its trajectory to be right on target by the time we make it to Mars.
Great. Thank you so much, Adam. And right now we are just a minute away from the acquisition of signal, so let's pause for a moment and watch our teams at work.
Ace Flight will be waiting for indication of acquisition of signal. Ace copies.
M20, ma'am, redefined report initial acquisition.
That's it. Copy that. Radio science.
Flight nav.
Go ahead, Nav.
We're seeing one-way data. 34 is AOS.
Didn't copy, Nav.
Yes, sir. We see AOS at 131531.
These copies. Thank you.
Flight telecom, I was about to pull up my contingency.
We now have an acquisition of signals. The rumbles now are of claps and cheers, and it's an amazing moment. And the years of blood, sweat, and tears from every person who worked on this mission is now realized as Perseverance makes its way to Mars. Now, if we still have Adam here, Adam, I want to know your reaction to getting the acquisition of signal.
Well, Raquel, it's very nice to have the spacecraft in a safe, separated, on its way to Mars. Nav looks good. We are hearing from the spacecraft. That was the only question. And it's not really much of a question, but it's just nice to have that confirmation. Our launch process is complete. The vehicle's on its way to Mars. And so the next chapter in Perseverance's mission can begin.
Great. And what are you looking forward to next?
I'm looking forward to, ideally, a very quiet and boring cruise to Mars as we prepare for the never boring and always stressful entry, descent, landing on the 18th of February.
Great. Thank you so much, Adam. And we hope you tune into our coverage of the landing happening on February 18th, 2021. Joshua and Mick, we here at JPL would like to thank you and the entire Launch Service Program and United Launch Alliance teams for all your amazing work today and all the work you do every day to make a launch like this possible. Now, Joshua, back to you at the Cape.
Raquel, congratulations to you and the team over there. Obviously, JPL, I think Adam's response is kind of what you'd expect from Adam of like, hey, check that box, but we got a lot of work to go.
Yes, yeah. I mean, the work here for the launch team, exciting day.
Yes.
We got this done. Our portion of this is done. Adam and the team now have Mars 2020 underway, and they've got a lot of work in front of them, too. And hopefully it is a quiet 7 months, and they get ready to go. But we are so excited to be able to perform this for them as our JPL customer. I know Tori Bruno and the ULA team are excited as well. And I just can't be I can't be more excited about how this went this
feels
morning.
Good.
Yes.
Hey, before we sign off today, we want to check in with the NASA launch manager, Omar Baez, to get some thoughts from him. Omar, kind of give us your response after seeing a successful process this morning.
Okay, so about a minute ago, we did get acquisition of the spacecraft signal. That signifies that JPL's Deep Space Network has locked onto the spacecraft. It's on its journey to Mars. Everything appears to be going nominally for them. They'll get to check out the spacecraft now, do those checks that they need to do to learn how to fly that vehicle the way it wants to fly on its way to Mars. Pretty interesting. We separated them at approximately 25,000 miles an hour, and it's going to take a couple of months to get to that February 18th landing date, which they're targeting. So it's an impressive amount of speed that we imparted to them, and that speed is what our job as Launch Services Program and United Launch Alliance is to provide that spacecraft. The heavy lifting now is on our partners at the Jet Propulsion Lab. To slow it down when it gets to Mars, up the parachutes, slow them down in the atmosphere, and extend that sky crane and land on Mars. So they've got a heck of a lot of work to do from here on out. Today's count went beautiful up until the last 20 minutes. Started to get exciting with some of the assets on the range having dropouts. And then a surprise call from the spacecraft mission director that we had a small earthquake in California at Pasadena that the folks in the control room felt. But they never lost signal, and they came back to me and said they were ready to proceed. We were able to lock down the time we were after. Launched on time, perfect launch from what I could see visually here in the control room. The orbital parameters look dead on. Our velocity is dead on. So we're on our way to Mars. There's no way back. So good luck to the Mars 2020 team. It's been a pleasure to be part of this. I've been with this roving Mars community since Sojourner, and through Spirit, Opportunity, and Curiosity. So it's a pleasure to be once again part of that little bit that becomes that club, that auto club of roving on Mars. And I just want to say I'm very proud of this team. This team has worked diligently to get here. It's hard enough to get to Mars, throw in COVID. Today we're dealing with a small earthquake, the threat of a tropical storm heading in our direction. It's just an immense amount of pressure on the team, and it's so relieving to be able to have gotten that mission off today on the first attempt. And with that, that closes the show for us.
Awesome. A big thanks to Omar. Appreciate him and his words. Obviously, a phenomenal effort from all 5 of our teams we talked about.
Yes.
So from LSP, congrats to this team. JPL, congrats to the U.S. Space Force. Congrats to ULA. Thank you to ULA for hosting us today. And then the Department of Energy. And a special thanks to a couple groups, the RADCC and the JIC. Those were 2 teams that were working behind the scenes for over 3 years to prepare for a contingency with the MMRTG.
That's correct.
Didn't have to exercise any of that work, which is what they wanted. Like that's
So
kind of one of
they
those
had a
things.
great day.
They had a great day. Yes, everybody had a great day. So, Mick, thanks to you as well for joining me.
Appreciate it, Joshua. Thanks for having me again. I've always loved doing this with you. And again, excited about the Mars mission. As Omar said, our prayers and good luck with the JPL team. They've got a lot of work in front of them, and we're just so excited to get them on their way in a perfect launch and orbit today. So thanks again for having me.
Yeah, the countdown to Mars continues. That's going to do it for us at the ASOC for the launch of the Mars 2020 mission with the Perseverance rover. Daryl, back to you.
All right, Mick Woltman and Joshua Santora, thank you both. A great job done by you. And again, congratulations to the Launch Services Program team here at NASA for the great launch, as well as United Launch Alliance getting that off. And I got to congratulate you as well, Dr. Moo. You're with JPL. You've been working on this for 7 years.
Yes.
Congratulations. How does it feel?
It's amazing to have this phase of the mission cemented now in time. Is amazing. But like Adam said, there's so much more to go.
A lot of work to do, but you know that your baby right there in front of you is on its way to Mars.
Yes, it is.
Very good. Well, engineers and scientists at NASA have spent years designing, as we've told you, and testing and building the Mars Perseverance rover, but we've also had help from a number of countries around the world.
Norway, France, and Spain, just to name a few, but also the European and Japanese space agencies. Here now is a toast to all of those who helped us get to Mars and help that Perseverance rover get ready to fly.
Congratulations for the successful launch of this fantastic new mission to the planet Mars.
Congratulations for the great work, despite all the obstacles set by COVID-19.
I want to congratulate everybody who made this mission happen thus far.
Thank you all for the passion and the commitment to make this epic happen.
Bravo et toutes mes félicitations, which means my heartfelt congratulations to all the teams involved in this magnificent adventure.
So you've been rewarded with a beautiful launch, and I hope you'll have a safe cruise to Mars. So well done the work so far. Let's keep going.
Skål to all teams for a successful flight.
Our international effort to reach Mars is more important now than it ever has been before.
This mission confirms that when we work together, we can overcome unbelievable challenges.
And to build a mission that truly deserves its name, Perseverance.
To persevere means to insist, to keep on, to continue trying tirelessly.
And if we persevere, we succeed. And that's why I think this is an appropriate name for this mission.
Perseverance has just started the journey to make history in Mars exploration.
It's the start of our collaboration, not only to go to Mars, but to bring back samples, the Mars Sample Return Campaign, and this is going to change our view of Mars forever.
Mars is an amazing place to explore.
Because exploration is inside the human being very nature.
Mars is essential to understand and know about our solar system, including our Earth.
We believe we can contribute to scientific discovery and future human exploration on Mars.
This exploration of Mars is of great global significance as it contributes to the humanity's search for a home away from planet Earth.
We need robotic precursor missions like Mars 2020 Perseverance to help us understand where we need to go and what we need to do when we get to Mars, but ultimately our objective as a globe is to put humans on the surface of Mars.
Together we're counting down to Mars, so go Perseverance!
一緒に火星に進出しましょう。行け、Perseverance.
Stiamo facendo insieme il conto alla rovescia per Marte. Vai Perseverance!
Ensemble, nous retournons vers Mars. Bon voyage, Perseverance.
Hop Perseverance.
Adelante Perseverance.
Hiya, Perseverance.
Together we are counting down to Mars. Go Perseverance.
And thank you so much to our international partners that you just saw there. They did a fantastic job. Now, before we let you go, we want to tell you about a little tradition that JPL has, where they did this, I guess, after the launch or before the launch with some peanuts, and Moo knows it well.
Yeah, in fact, Perseverance, little baby Percy brought us some peanuts here to divvy out, so let me give you some.
Look at there.
It actually started with a landing event. So Rangers 1 through 6 didn't go as planned. And then with Ranger 7, it landed successfully on the moon. And they were thinking, what was the difference between Rangers 1 through 6 and 7? And it was these lucky peanuts.
The lucky peanuts.
Yeah.
And so ever since then, I guess they've been having peanuts.
Exactly.
To
for
get
every landing, and now launches.
Well, and now we've got ours in our hand. We're going to hold off because we got a little more reading to do, but we're ready to go with our peanuts.
Yes. Yes, thank you so much for watching NASA's launch coverage of Mars 2020. Stay tuned to NASA TV and our social media channels for updates to the mission.
Yeah, coming up in just a bit at 11:30 Eastern Daylight Time, we will have a post-launch news conference right here on NASA TV, so stay tuned for that. And of course, to the next big moment that we've been talking about, the landing of the Perseverance rover on the surface of Mars 7 months from now. That date, February 18th, 2021. So for now, we leave you with highlights from the thrilling liftoff earlier this morning. Take care, everyone, and remember, keep looking up. Cheers.
Cheers.
7, 6, 5, 4. Engine ignition. 2, 1, 0.
0. Release.
And liftoff. As the countdown to Mars continues, the perseverance of humanity launching the next generation of robotic explorers to the Red Planet.
And Atlas TU has gone to closed loop control. Coming up on third.
Mars and Earth have approximately the same land mass. Even though Mars has only 15% of the Earth's volume and just over 10% of the Earth's mass, around 2/3 of the Earth's surface is covered in water. Martian surface gravity is only 37% of the Earth's, meaning you could leap nearly 3 times higher on Mars. Mars is home to the tallest mountain in the solar system. Olympus Mons, a shield volcano, is 21 kilometers high and 600 kilometers in diameter. Despite having formed over billions of years, evidence from volcanic lava flows is so recent many scientists believe it could still be active. Only 18 missions to Mars have been successful. As of September 2014 there have been 40 missions to Mars, including orbiters, landers and rovers but not counting flybys. The most recent arrivals include the Mars Curiosity mission in 2012, the MAVEN mission, which arrived on September 22, 2014, followed by the Indian Space Research Organization's Mangalyaan orbiter, which arrived on September 24, 2014. The next missions to arrive will be the European Space Agency's ExoMars mission, comprising an orbiter, lander, and a rover, followed by NASA's InSight robotic lander mission, slated for launch in March 2016 and a planned arrival in September 2016. Mars has the largest dust storms in the solar system. They can last for months and cover the entire planet. The seasons are extreme because its elliptical, oval-shaped, orbital path around the Sun is more elongated than most other planets in the solar system. On Mars the Sun appears about half the size as it does on Earth. At the closest point to the Sun, the Martian southern hemisphere leans towards the Sun, causing a short, intensely hot summer, while the northern hemisphere endures a brief, cold winter. At its farthest point from the Sun, the Martian northern hemisphere leans towards the Sun, causing a long, mild summer, while the southern hemisphere endures a lengthy, cold winter. Pieces of Mars have fallen to Earth. Scientists have found tiny traces of Martian atmosphere within meteorites violently ejected from Mars, then orbiting the solar system amongst galactic debris for millions of years, before crash landing on Earth. This allowed scientists to begin studying Mars prior to launching space missions. Mars takes its name from the Roman god of war. The ancient Greeks called the planet Ares, after their god of war. The Romans then did likewise, associating the planet's blood red color with Mars, their own god of war. Interestingly, other ancient cultures also focused on color. To China's astronomers it was the fire star, whilst Egyptian priests called on her Desha, or the red one. The red color Mars is known for is due to the rock and dust covering its surface being rich in iron. There are signs of liquid water on Mars. For years Mars has been known to have water in the form of ice. The first signs of trickling water are dark stripes or stains on crater wall and cliffs seen in satellite images. Due to Mars' atmosphere, this water would have to be salty to prevent it from freezing or vaporizing. One day Mars will have a ring. In the next 20-40 million years Mars' largest moon Phobos will be torn apart by gravitational forces, leading to the creation of a ring that could last up to 100 million years. Mars is the fourth planet from the Sun and is the second smallest planet in the solar system. Named after the Roman god of war, Mars is also often described as the red planet due to its reddish appearance. Mars is a terrestrial planet with a thin atmosphere composed primarily of carbon dioxide. Mars planet profile. Equatorial diameter, 6,792 kilometers. Polar diameter, 6,752 kilometers. Mass, 6.42 by 10 carat 23 kilograms, 10.7% Earth. Moons, 2. Phobos and Deimos. Orbit distance, 227,943,824 kilometers, 1.52 astronomical units. Orbit period, 687 days, 1.9 years. Surface temperature, -153 to 20 degrees Celsius. First record, 2nd millennium BC, recorded by Egyptian astronomers. Mars and Earth have approximately the same land mass. Even though Mars has only 15% of the Earth's volume and just over 10% of the Earth's mass, around 2/3 of the Earth's surface is covered in water. Martian surface gravity is only 37% of the Earth's, meaning you could leap nearly 3 times higher on Mars. Mars is home to the tallest mountain in the solar system. Olympus Mons, a shield volcano, is 21 kilometers high and 600 kilometers in diameter. Despite having formed over billions of years, evidence from volcanic lava flows is so recent many scientists believe it could still be active. Only 18 missions to Mars have been successful. As of September 2014, there have been 40 missions to Mars, including orbiters, landers and rovers, but not counting flybys. The most recent arrivals include the Mars Curiosity mission in 2012, the MAVEN mission, which arrived on September 22, 2014, followed by the Indian Space Research Organization's Mangalyaan orbiter, which arrived on September 24, 2014. The next missions to arrive will be the European Space Agency's ExoMars mission, comprising an orbiter, lander, and a rover, followed by NASA's InSight robotic lander mission, slated for launch in March 2016 and a planned arrival in September 2016. Mars has the largest dust storms in the solar system. They can last for months and cover the entire planet. The seasons are extreme because its elliptical, oval-shaped, orbital path around the Sun is more elongated than most other planets in the solar system. On Mars the Sun appears about half the size as it does on Earth. At the closest point to the Sun, the Martian southern hemisphere leans towards the Sun, causing a short, intensely hot summer, while the northern hemisphere endures a brief, cold winter. At its farthest point from the Sun, the Martian northern hemisphere leans towards the Sun, causing a long, mild summer, while the southern hemisphere endures a lengthy, cold winter. Pieces of Mars have fallen to Earth. Scientists have found tiny traces of Martian atmosphere within meteorites violently ejected from Mars, then orbiting the solar system amongst galactic debris for millions of years, before crash landing on Earth. This allowed scientists to begin studying Mars prior to launching space missions. Mars takes its name from the Roman god of war. The ancient Greeks called the planet Ares, after their god of war. The Romans then did likewise, associating the planet's blood red color with Mars, their own god of war. Interestingly, other ancient cultures also focused on color. To China's astronomers it was the fire star, whilst Egyptian priests called on her Desha, or the red one. The red color Mars is known for is due to the rock and dust covering its surface being rich in iron. There are signs of liquid water on Mars. For years Mars has been known to have water in the form of ice. The first signs of trickling water are dark stripes or stains on crater wall and cliffs seen in satellite images. Due to Mars' atmosphere, this water would have to be salty to prevent it from freezing or vaporizing. One day Mars will have a ring. In the next 20-40 million years, Mars' largest moon Phobos will be torn apart by gravitational forces, leading to the creation of a ring that could last up to 100 million years. Mars is the fourth planet from the Sun and is the second smallest planet in the solar system. Named after the Roman god of war, Mars is also often described as the red planet due to its reddish appearance. Mars is a terrestrial planet with a thin atmosphere composed primarily of carbon dioxide. Mars planet profile. Equatorial diameter, 6,792 kilometers. Polar diameter, 6,752 kilometers. Mass, 6.42 by 10 carat 23 kilograms, 10.7% Earth. Moons, 2, Phobos and Deimos. Orbit distance, 227,943,824 kilometers, 1.52 astronomical units. Orbit period, 687 days, 1.9 years. Surface temperature, -153 to 20 degrees Celsius. First record, 2nd millennium BC, recorded by Egyptian astronomers. Mars and Earth have approximately the same land mass. Even though Mars has only 15% of the Earth's volume and just over 10% of the Earth's mass, around 2/3 of the Earth's surface is covered in water. Martian surface gravity is only 37% of the Earth's, meaning you could leap nearly 3 times higher on Mars. Mars is home to the tallest mountain in the solar system. Olympus Mons, a shield volcano, is 21 kilometers high and 600 kilometers in diameter. Despite having formed over billions of years, evidence from volcanic lava flows is so recent many scientists believe it could still be active. Only 18 missions to Mars have been successful. As of September 2014, there have been 40 missions to Mars, including orbiters, landers and rovers, but not counting flybys. The most recent arrivals include the Mars Curiosity mission in 2012, the MAVEN mission, which arrived on September 22, 2014, followed by the Indian Space Research Organization's Mangalyaan orbiter, which arrived on September 24, 2014. The next missions to arrive will be the European Space Agency's ExoMars mission, comprising an orbiter, lander, and a rover, followed by NASA's InSight robotic lander mission, slated for launch in March 2016 and a planned arrival in September 2016. Mars has the largest dust storms in the solar system. They can last for months and cover the entire planet. The seasons are extreme because its elliptical, oval-shaped, orbital path around the Sun is more elongated than most other planets in the solar system. On Mars, the Sun appears about half the size as it does on Earth. At the closest point to the Sun, the Martian southern hemisphere leans towards the Sun, causing a short, intensely hot summer, while the northern hemisphere endures a brief, cold winter. At its farthest point from the Sun, the Martian northern hemisphere leans towards the Sun, causing a long, mild summer, while the southern hemisphere endures a lengthy, cold winter. Pieces of Mars have fallen to Earth. Scientists have found tiny traces of Martian atmosphere within meteorites violently ejected from Mars, then orbiting the solar system amongst galactic debris for millions of years, before crash landing on Earth. This allowed scientists to begin studying Mars prior to launching space missions. Mars takes its name from the Roman god of war. The ancient Greeks called the planet Ares, after their god of war. The Romans then did likewise, associating the planet's blood red color with Mars, their own god of war. Interestingly, other ancient cultures also focused on color. To China's astronomers it was the fire star, whilst Egyptian priests called on Herdesha, or the red one. The red color Mars is known for is due to the rock and dust covering its surface being rich in iron. There are signs of liquid water on Mars. For years Mars has been known to have water in the form of ice. The first signs of trickling water are dark stripes or stains on crater wall and cliffs seen in satellite images. Due to Mars' atmosphere, this water would have to be salty to prevent it from freezing or vaporizing. One day Mars will have a ring. In the next 20-40 million years Mars' largest moon Phobos will be torn apart by gravitational forces, leading to the creation of a ring that could last up to 100 million years. Mars is the fourth planet from the Sun and is the second smallest planet in the solar system. Named after the Roman god of war, Mars is also often described as the red planet due to its reddish appearance. Mars is a terrestrial planet with a thin atmosphere composed primarily of carbon dioxide. Mars planet profile. Equatorial diameter, 6,792 kilometers. Polar diameter, 6,752 kilometers. Mass, 6.42 by 10 carat 23 kilograms, 10.7% Earth. Moons, 2, Phobos and Deimos. Orbit distance, 227,943,824 kilometers, 1.52 astronomical units. Orbit period, 687 days, 1.9 years. Surface temperature, -153 to 20 degrees Celsius. First record, 2nd millennium BC, recorded by Egyptian astronomers. Mars and Earth have approximately the same land mass. Even though Mars has only 15% of the Earth's volume and just over 10% of the Earth's mass, around 2/3 of the Earth's surface is covered in water. Martian surface gravity is only 37% of the Earth's, meaning you could leap nearly 3 times higher on Mars. Mars is home to the tallest mountain in the solar system. Olympus Mons, a shield volcano, is 21 kilometers high and 600 kilometers in diameter. Despite having formed over billions of years, evidence from volcanic lava flows is so recent many scientists believe it could still be active. Only 18 missions to Mars have been successful. As of September 2014 there have been 40 missions to Mars, including orbiters, landers and rovers but not counting flybys. The most recent arrivals include the Mars Curiosity mission in 2012, the MAVEN mission, which arrived on September 22, 2014, followed by the Indian Space Research Organization's Mangalyaan orbiter, which arrived on September 24, 2014. The next missions to arrive will be the European Space Agency's ExoMars mission, comprising an orbiter, lander, and a rover, followed by NASA's InSight robotic lander mission, slated for launch in March 2016 and a planned arrival in September 2016. Mars has the largest dust storms in the solar system. They can last for months and cover the entire planet. The seasons are extreme because its elliptical, oval-shaped, orbital path around the Sun is more elongated than most other planets in the solar system. On Mars the Sun appears about half the size as it does on Earth. At the closest point to the Sun, the Martian southern hemisphere leans towards the Sun, causing a short, intensely hot summer, while the northern hemisphere endures a brief, cold winter. At its farthest point from the Sun, the Martian northern hemisphere leans towards the Sun, causing a long, mild summer, while the southern hemisphere endures a lengthy, cold winter. Pieces of Mars have fallen to Earth. Scientists have found tiny traces of Martian atmosphere within meteorites violently ejected from Mars, then orbiting the solar system amongst galactic debris for millions of years, before crash landing on Earth. This allowed scientists to begin studying Mars prior to launching space missions. Mars takes its name from the Roman god of war. The ancient Greeks called the planet Ares, after their god of war. The Romans then did likewise, associating the planet's blood-red color with Mars, their own god of war. Interestingly, other ancient cultures also focused on color. To China's astronomers it was the fire star, whilst Egyptian priests called on her Desha, or the red one. The red color Mars is known for is due to the rock and dust covering its surface being rich in iron. There are signs of liquid water on Mars. For years Mars has been known to have water in the form of ice. The first signs of trickling water are dark stripes or stains on crater wall and cliffs seen in satellite images. Due to Mars' atmosphere, this water would have to be salty to prevent it from freezing or vaporizing. One day Mars will have a ring. In the next 20-40 million years Mars' largest moon Phobos will be torn apart by gravitational forces, leading to the creation of a ring that could last up to 100 million years. Mars is the fourth planet from the Sun and is the second smallest planet in the solar system. Named after the Roman god of war, Mars is also often described as the red planet due to its reddish appearance. Mars is a terrestrial planet with a thin atmosphere composed primarily of carbon dioxide. Mars planet profile. Equatorial diameter, 6,792 kilometers. Polar diameter, 6,752 kilometers. Mass, 6.42 by 10 carat 23 kilograms, 10.7% Earth. Moons, 2, Phobos and Deimos. Orbit distance, 227,943,824 kilometers, 1.52 astronomical units. Orbit period, 687 days, 1.9 years. Surface temperature, -153 to 20 degrees Celsius. First record, 2nd millennium BC, recorded by Egyptian astronomers. Mars and Earth have approximately the same land mass. Even though Mars has only 15% of the Earth's volume and just over 10% of the Earth's mass, around 2/3 of the Earth's surface is covered in water. Martian surface gravity is only 37% of the Earth's, meaning you could leap nearly 3 times higher on Mars. Mars is home to the tallest mountain in the solar system, Olympus Mons.
Engine ignition, 2, 1, 0.
Release.
And liftoff. As the countdown to Mars continues, the perseverance of humanity launching the next generation of robotic explorers to the Red Planet.
And we have good indication of SRB jettison of all 4 SRBs. We have good indication of payload-carrying jettison. And we have successful separation of Mars 2020 with the Perseverance rover.
And welcome to NASA's post-launch press conference here at the Kennedy Space Center. I'm Daryl Nail, and as you just saw, there was a successful launch of an Atlas V rocket by United Launch Alliance and NASA, sending the Mars Perseverance rover to the Red Planet. We have some special guests here now to talk about the launch, and I want to get to those right now. To my left, we begin with Jim Bridenstine, the NASA administrator. We also have Thomas Zurbuchen, NASA's Science Associate Administrator. Lori Glaze is here. She is the Planetary Science Division Director at NASA headquarters. And we have Matt Wallace, Deputy Project Manager with NASA's Jet Propulsion Laboratory. Omar Baez, he is our Launch Director at NASA's Launch Services Program. And Tori Bruno, President and CEO of United Launch Alliance. Thank you all for being here. We're going to get started with our administrator and a few comments. Of course, it was an incredible launch here at the Kennedy Space Center, and a successful one at that, sending the rover on its way. We understand there is a small communication issue with the spacecraft, and we're going to let Jim start us off and talk about that. Jim?
Oh, you bet. Thank you, Daryl. So first of all, it was an amazing launch, very successful. It went right on time, and of course, it is on a trajectory that has been done now with pinpoint accuracy. The spacecraft rotates, so it's stable, and it is in fact on its way to Mars. You mentioned the communications issue, and we can call it an issue. I know there's maybe some folks in the media that would call it an issue. But really, it's something that we've seen before with other Mars missions, as a matter of fact. And what's happening is, we're using the Deep Space Network to receive the signals from the spacecraft right now. Well, the Deep Space Network is a very sensitive receiver. It's designed to capture, very faint signals from deep space. And of course, the spacecraft right now is yes, it's in deep space. It's a good distance from the Earth, but it is not the distance that we would normally be receiving from using the Deep Space Network. So what this does is it puts us in a position where the carrier wave is actually, we have a strong carrier wave, a strong signal, but we haven't been able to lock onto the modulation of that signal to receive the data. This is not unusual. Everything is going according to plan. We do need to, fine-tune our receiving stations on the ground and do some things to capture that signal and lock on. But I think we're in great shape. It was a great day for NASA. And I just want to say thank you to our partners at United Launch Alliance. Tori Bruno, your team did an absolute magnificent job. It couldn't have gone any better from a launch perspective. And of course, our team at JPL, which has worked so hard to put this mission together. So the whole NASA team is grateful for the people that made this come together. So thank you, Daryl, and look forward to hearing from the others and answering questions.
Absolutely, and thank you, Jim. Let's start with you, Dr. Z. Successful launch. There's still a lot to go. What are your feelings now after experiencing this and seeing this science mission on its way?
I'm relieved. It's a space mission now, right? It used to be an engineering project on the ground. It's a space mission now, and it's on the way to Mars. That's exactly what we hoped we will be at right now. And you know, the one thing that I want to do also is just add my gratitude. You know, Launch Services, United Launch Alliance, you know, getting this done. Of course, JPL. You know, and that many partners, both international and domestic commercial partners that got us there. And I just really want to thank. I want to also tell you about something else I'm proud of, and that is that this entire launch, from the beginning, with all the uncertainty that the launch brings, through now, we do so with cameras on, and we communicate clearly and directly and openly. We believe, and I know we feel exactly the same way, Jim, is that inspiration comes from taking that risk and making it really clear and open what all the successes are. And every once in a while, you know, where we need 2 attempts to get this down and you know, on the green and down, you know. So the point is, this is just a space mission. I look at 100 space missions or so each day in my email, and issues of that type and others occur, and we communicate that openly, and I just think that's where the inspiration comes from. I was so excited, for example, to meet these 2 7th graders that did name Perseverance and Ingenuity, and just learned from them how inspired they were from this launch. So I really just so grateful and so excited for this mission.
You can certainly tell they enjoyed their time here watching from the 5th floor and getting all the excitement that goes into watching something they helped name go up into space. Lori, let's get to you now. You've got something a little fun planned for us, right?
I do, but before we get to that, I want to just take a moment also to thank, of course, ULA and LSP and JPL and all of the scientists and engineers that worked on the Mars 2020 project, all of them that got us here today. We wouldn't be here without the entire team, so thanks go to all of them. I do have something a little special for folks today. We are, of course, with this mission, taking the whole world with us on our way to Mars. And as part of that, we ran a campaign with JPL to invite the world to help us with the countdown to Mars. And so what I'd like to do is share that a little short video that we've put together with the help of folks all around the world.
Let's light this candle. 10, 9,
8,
7, 6, 5,
4,
3,
2,
1.
0. And liftoff as the countdown to Mars continues.
Blast off. Lift off. Lift off. Lift off.
The perseverance of humanity launching the next generation of robotic explorers to the Red Planet.
Bon voyage. Good perseverance.
Well, that was great, Lori.
Great.
Really enjoyed seeing all those kids from around the world helping out and contributing some of their creative genius to our mission here. We want to turn now our attention to Matt Wallace, the Deputy Project Manager, who looks like you were doing some communicating yourself over there. Tell us what the, what the latest is with the rover.
Yeah, I was just getting an update. Let me just start, though, by saying, express my gratitude and the gratitude of the team for the people over here to my right. which have supported this project for 7-8 years, for a long time, especially over the last couple months when we were going through the the very strenuous period dealing with the pandemic. It really took the entire agency to step up and help us, and they didn't hesitate, and they did it, and we really appreciate that. I also want to just say you're going to hear from the ULA and Launch Services team after me, but they gave us a perfect launch this morning, right down the middle. Couldn't have aimed us any better. We look great coming off the Centaur, and they really pushed hard to keep us on this limited planetary launch window in 2020. As most of you know, if you miss this window, you got to wait a couple years, and so it was critically important for us to hit this. And I can't say enough about the professionalism and the support they gave us over the last couple months in particular. And then also, I want to thank the team. The team out there, thousands of people that have really stepped up and made this a special mission. As people have alluded to, Perseverance has become a pretty good name for this mission. So let me talk a little bit about what we've been dealing with just today. As I said, the spacecraft looked great pre-launch. We went into launch mode. We get telemetry via the launch vehicle, telemetry communication all the way through separation of the upper stage. And then we go into a period where we have to wait until we come out of the eclipse of the Earth. Essentially, the Earth is shadowing the sun, and therefore the spacecraft doesn't have a lot of power. And so we don't turn on our high power transmitter, and we wait until we're in a better power situation to do that. So at about 9:15 or so this morning, as expected, the transmitter turned on. The signal strength looked very good at the receive station. There were really no indications of any issues. The navigation signal, the Doppler that we analyzed to make sure we're on the right trajectory, looked very good. The one problem we had is we couldn't, the terminology that we use is we couldn't lock up our telemetry. And so basically what that means is that we have to modulate our telemetry on a subcarrier, and then we have to demodulate that subcarrier, and which sounds pretty technical, but basically it allows us to read the information and the data coming from the spacecraft. Now, it turns out that the Deep Space Network is really designed to talk to spacecraft that are a long way away. Spacecraft like Voyager, which are tens of billions of miles away. And so they have very sensitive receivers, very big antennas, and to configure them, in fact, to talk to a spacecraft that is this close to the Earth is a little out of the ordinary. And so we know, and we have had issues in the past before. In fact, the last mission I worked on, the Curiosity mission, which launched in 2011, had this issue where we were basically saturating the receiver at the ground station. And so it takes us a little while to essentially figure out how to configure the ground station such that we're able to demodulate that telemetry signal and get the information from the spacecraft. And that's what we've been working through over the last hour and a half or so since the transmitter turned on. I did, just as the administrator was speaking, I did just get a text that we were able to lock up on that telemetry. And so we'll be starting to get some information on spacecraft and spacecraft health very soon. The good news, though, is that all the indications that we have, and we have quite a few, are that the spacecraft's just fine. It's a very stable spacecraft. It's a spinning spacecraft. Our Centaur upper stage, in fact, spins us at about 2.5 revolutions per minute, which means the spacecraft is hard to kind of knock off course. It's like a spinning top. You can't knock it over. And so it's very stable. We know it's getting good power. We know, as I said, the transmitter's on. And so it's really just taking a look now at the telemetry, which we've now locked up on, and getting a health status from the team. And so that'll happen shortly.
All right. Thank you very much for that
Sure.
update. That is great news to hear. Let's turn now to Omar Baez, the launch director from NASA's Launch Services program, getting a lot of accolades. So, Mar, how did you feel the team performed today?
Oh, fantastic. Honored, proud. Those are the kind of words that I can think of right now. Ecstatic, you know. It was a very quiet count for us. About the only excitement was a couple of instruments dropping out with the range, and then at about 20 minutes, Matt came over to us and said, "Hey, we just had a earthquake in Pasadena, and we'll see if we're still okay as far as the control room there and the information they were getting." And they responded back really quick. And I'm pleased to say we hit it right at the beginning of the window. The vehicle performed perfectly. We released them at just over 25,000 miles an hour, so we'll make that separation distance in a couple of days that you need for locking on. It'll become easier. So Daryl, just proud to be a part of this. I've been with this with Matt and company, and so has the predecessor to the Launch Services program. From when we did Sojourner, we had less gray hair then, but it's just a proud moment, and I'm glad to be a part of it. And I'm glad that our program could provide what they needed to get this on its way.
Congratulations again to your team. You certainly had a good partner in this effort, United Launch Alliance. And so now we'll turn to Tori Bruno, the CEO and president of ULA. Tori, you said that this rocket would leap off the pad, and indeed it did. That thing got out of here in a hurry.
Yes, it did. It was a beautiful day, as you saw in the video, and the winds were nearly dead calm out at the pad. And so, as you heard, we ignited. The Atlas performed really nominally throughout the mission, and we ended with just an extraordinarily accurate orbital insertion. And really the only excitement that we had today at all is what Omar referred to, where people in California thought they felt an earthquake, but really they were just feeling mighty Atlas crouching down to leap off the Earth.
Thank you very much, Tori. We appreciate that. A little rumble in California and some rumble here in Florida. All right, we are now going to go to the phones and get some questions from our media members out there, and we'll also take questions from social media at the hashtag Countdown to Mars. We will begin with Paul Brinkman, who's on the phone, who is with UPI. Paul, go ahead.
Hi, yeah, thanks very much. So we're talking about launch here, but all of this is aimed at proper Mars arrival in 7 months. So can I ask one of you, I guess Matt Wallace, to talk about that next big step in this process? How do you verify that the craft has properly arrived at Mars? And then for the entry and landing, is this basically a total copy of the EDL for our Curiosity, or how is it different?
Yeah, sure. I can take a shot at some of those. Well, we'll spend the next 6.5 months or so in cruise, and we'll do a lot of engineering checkouts and health checks and make sure the spacecraft is ready to go for entry, descent, and landing. It is definitely by far the most difficult part of the mission. The spacecraft has to perform the entire process of getting down to the surface autonomously. There's no human interaction with the spacecraft during that period of time. And basically we start prepping for it maybe 8 days out or so. And as we get closer and closer to the outer atmosphere, there's more and more autonomy, especially this spacecraft essentially starts to do what it needs to do on its own without our interaction. And then we do land in a way that's very similar to a Curiosity. We were able to leverage a lot of the investment we made in that mission, getting Curiosity down to Gale Crater. So we come in, on the order of 12,000 miles an hour. Our entry capsule will slow us down. We will steer that entry capsule hypersonically so that we aim right at our landing site. And then when we're still moving at about Mach 2, we inflate our big supersonic parachute. It's about a 70-foot chute. That's an exciting moment in the mission, and that'll slow us down to maybe 150 miles an hour or so. And then the heat shield, the bottom of the entry capsule, drops off when we start to acquire the ground. At this point, we do something a little bit different than Curiosity did. We have a new capability. It's a hazard avoidance capability, and it's a very powerful new system. We call it terrain relative navigation, and it's actually enabled us to target Jezero Crater, which is a location we could not have gotten into with the Curiosity MSL mission. There are just too many landing hazards. But the way it works is we take a picture as we're coming down, and then we find ourselves in a map that we have stored on board from orbital imagery. And once we know where we are in that map, we essentially divert the spacecraft away from the hazards that could be dangerous to it during landing. And we do that during what we call powered descent. We have something called a descent stage, which carries the rover with 8 big main engines down to the surface. As the rover gets close to the surface, it deploys down on a tether. That's a maneuver we call the sky crane maneuver. The rover will touch down on its wheels, we'll cut the tether, and we'll be ready to go on the surface. So, so there are a lot of similarities, but we have some new capabilities as well to help us get into these more scientifically interesting sites like Jezero.
Thank you very much. The only thing is we have to wait 6.5 months for all this. Thanks for describing those exciting moments that will be happening in that time, February 18th, right, 2021. Our next question comes to us from Marcia Dunn with Associated Press. Go ahead, Marcia.
Yes, hi. Probably for Matt. I'm wondering, provided this lock on the data stays solid, how much longer do we have to wait to get a full read on the spacecraft health? And I'm wondering, up until the time you got that text a few minutes ago, if this led to some extra sweaty palms, a little bit of heart fluttering until after a long day. Thanks.
I'm not sure I heard the entire question, but I think the first part was associated with how long it would take before we had some spacecraft telemetry. The team will be pouring through that telemetry, as we speak. I would say another 30 to 60 minutes or so. We'll have a pretty good understanding of, the different spacecraft systems. They'll be looking at the power production out of the solar arrays. They'll look at the temperatures around the spacecraft, the thermal conditions. We'll obviously be taking a look at the telecommunication systems, be looking for any other faults or anomalies, obviously, on the spacecraft. But I would say on the order of 30 to 60 minutes or so from now, we'll have an update probably.
And the second part of our question was, how are you feeling after this successful launch and this first part of the mission?
There's always a bit of relief when you get through the launch cycle and the spacecraft separates. The spacecraft is really designed to operate, as I think Thomas was saying, in space. That's where it's happiest. Most of the problems we run into are because we're in a test configuration that's not really flight-like, interestingly enough. And so I think the team is obviously very relieved to be on our way, and the spacecraft is generally is as well. So yeah.
Very good. Our next question comes to us from Lauren Grush with The Verge. Lauren?
Hi, thank you so much for taking my question, and congrats on the launch today. I'm curious, is there any extra risk introduced by not being able to communicate with the spacecraft right at the time of signal acquisition? Or is it really just peace of mind ahead of your first big maneuver? And also, had you prepped for the possibility of this communication problem since it happened with Curiosity? Thank you.
What was the first part of the question? I couldn't quite hear.
She was asking about the communication with the spacecraft in terms of getting that acquisition to signal. Is it a problem that you don't lock in initially?
No, well, as I said, the spacecraft is as I just finished saying, is really designed to be in space. It's a very inherently stable spacecraft. We've got plenty of time to work through the communication issues. There's nothing that we need to do urgently. In fact, we got such a good, insertion from the launch vehicle. We've got plenty of time before we have to make our first trajectory correction maneuver. Nominally, it's about 15 days after launch, but we probably have time well beyond that based on how well we did. So we got plenty of time to, to get the signal and to start interacting with the spacecraft and doing those sorts of things.
All right. Let's turn now to Irene Klotz, who is with Aviation Week. Irene, go ahead.
Thanks very much. I may have, I'm not sure if I heard this correctly, but once the spacecraft reaches, is it 25,000 miles that this issue becomes moot, whether or not you're able to do the comms by modulating the signal or not? And that's for Matt. In other words, how far away does Perseverance need to be before it enters the true deep space mode of communication?
Yeah, I think it was Tori or maybe Omar that said the spacecraft's moving pretty fast, 25,000 miles an hour when it comes off that upper stage. And so the point that they were making is that we're putting distance between the spacecraft and the Earth pretty quickly. And so that helps a lot with respect to the saturation of the ground station, radios. And so really within hours, the power will drop. And that can help, certainly, yeah.
And real quick, Omar, what were the numbers on the release of the spacecraft?
It's just over 25,000 miles
Per hour. Okay, very good. All right, let's turn now to Russell Pins, who is with Pacific Rim Media. Russell, go ahead and ask your question.
Good morning. Yeah, that's Russell Pounds, calling from Alaska today. And this is for Administrator Bridenstine. The question is, when does the light go on for students that America's investment in space exploration is worth the money? And then as a follow-up for adults, if it's a different kind of time when they realize, oh, this is worth our while, when is it that happens?
Oh, I think it's already happened, and I think, when you think about Mars Perseverance, that's evidence that it has happened. We just had a few folks here on the panel talk about Sojourner and its success, and then of course Spirit and Opportunity and the success of those robots, and then Curiosity and now Perseverance. Look, every single one of these missions gets more complex and more sophisticated, and right now we have the single most sophisticated, complex robot ever sent to another world, and so we're very excited about it. But I think the American people see the benefit of these activities, not just in terms of science, but also in the development of technology that we all benefit from. So I think as far as the American public goes, there's a lot of enthusiasm for these missions, and of course, as far as children go, these are the kind of moments where people decide. Young folks can decide, wow, that's something I want to do when I grow up, and they go into the STEM fields and they get interested in STEM activities. So I think all of America is very proud and excited about this mission, and the ones that in fact came before it, and the ones that are operating on Mars right now today.
We certainly got a sample of that from Lori's video and some of the kids that we saw there. Let's pause for a second and ask a question to Omar while we are waiting for these 7 months for Mars Perseverance to land. What is next for LSP?
So LSP's next launch is the Microfrylix Sentinel-6 mission out of Vandenberg, and that's in November. But we do have a very full manifest of other missions that are in queue. So yeah, next up in the lineup for launch, Sentinel-6, and quite a few other missions to fly out in a year later.
Good to hear the manifest is full over there. For Tori, ULA has launched 4 previous missions to Mars on Atlas V. Was there anything different that you did with this configuration that was different than the others?
Yeah, there was. So there were probably 2 important things that were different. The first was that the planetary protection requirements in terms of cleanliness and biological contamination were updated for this mission, making this probably the cleanest spacecraft that has ever gone to space. That was a significant challenge. And then we combined that with another new thing, which was to bring in the nuclear battery, the multi-mission radioisotope thermoelectric generator, laid into the flow and actually breach that encapsulated volume where we keep the ultra-clean spacecraft, where it was prepared in its own facility in order to install the battery out near the pad in what is essentially an outdoor vertical integration facility. And so that meant constructing a clean room that could be put onto the VIF on a platform and then have people come in there and do that work while maintaining all of those protocols, both handling of the plutonium as well as protecting Mars from the spacecraft itself so that the experiments could be successful. So that was a pretty big challenge for our people, and of course they had to do it in the midst of COVID just like your teams did, and I could not be more proud and more humbled by the courage and the dedication of my launch team that just pulled all that off.
And congratulations on that great work. Going to go back to the phone bridge now, and we'll get a question from Leo Enright, who is with Irish Television.
Thanks very much, and congratulations on the launch today. A couple of questions. One for the rocket people, as it were, about spacecraft separation. We saw a blink and you miss it video of spacecraft SEP. I just wondered if we're going to see any further video, or is that it? And then for Matt Wallace, if I may, could you be a bit specific about what time of day you're planning to land on Mars? It helps us TV people plan ahead. Is it morning, noon, or middle of the night?
Well, as far as the landing goes, I'll have to get you the specific information, make sure I don't give you the wrong time. And I'll let Omar and Tori answer the other question.
I can go. Yeah, so we have a little bit more video than that. I mean, we can certainly make it available, but what you saw is what you saw. It came off very, very clean, 2.5 RPM, and it just gets further and further away until it disappears. But what I will commit to do for you, as I always do for every mission, I will publish the bullseye chart, as we call it, that shows you all of the significant orbital parameters relative to the error that we were allowed that would have been within the spacecraft's capability to correct its trajectory. It's going to be pretty close to plus or minus perfect, and I will tweet that probably in the next day or two once we get it all processed.
Forward to that report card.
The video of it separating is one thing, but the video, we're going to get kind of new imagery that we've never been able to get before on the entry, descent, and landing. Can you talk about that?
This mission has more cameras on it than any mission we've ever sent before, and I think the images and the video that we're going to get back from the Perseverance rover during that entry, descent, and landing, and then once it's on the surface as well, is just going to be absolutely stunning. We'll be able to capture what it looks like coming down. I believe there's cameras looking up to get the parachute. We've got, it is extremely well equipped, and I think it's, again, going to be something that we can feel like we're actually there riding along with Perseverance on the way down.
We're going to see images of the sky crane.
We are, yeah. And in fact, what the administrator is referring to is we took some ruggedized commercial cameras, the type of kind of sport cameras you might see in extreme sport enthusiasts and that type of thing. And we basically distributed them around the spacecraft. And so we will, in fact, be able to see that big 70-foot supersonic parachute inflate in a tenth of a second, and we'll be able to see those big main engines fire on the descent stage, and the rover drop down on its tether. we'll be able to see the rover touch down and the descent stage fly away. And I do want to say that one of the reasons, one of the things that inspired us to add these cameras were the terrific imagery that we see coming off the launch vehicle. You know, it was time to have the opportunity to see a spacecraft land on another planet for the first time. It was time to do that, and we were pleased to be able to get them on the spacecraft.
I've seen video from a rocket landing on Earth, and now to see this video landing on another planet, it just something I'm really looking forward to. And of course, stay tuned to NASA's social media accounts. You will likely see it there pretty quickly. We're going to go now to Lori to tell us about the Mars helicopter Ingenuity.
All right. So this is going to be a fantastic experiment. I think we're really, really looking forward to this. I'm not sure that people really can sometimes grasp just how difficult it is to fly. And this is going to be, of course, our first ever demonstration of powered flight on another planet. But if you think what's required to fly, to get lift from a wing, you need air to do that, of course. And the atmosphere on Mars is about 1% of the density of Earth's atmosphere. And so without that air, getting lift and being able to actually fly is something that's extremely challenging. But the engineers out at JPL demonstrated that they could actually get that lift and fly a helicopter in that very, very low density type of atmosphere. And so we are really, really excited to do this and demonstrate that capability. I think going forward for scientific purposes and also in preparation for human exploration, I think these types of aerial robotic capabilities are really going to add to the type of science we can do. We'll be able to use such a helicopter to do things like do some pre-surveillance, do some reconnaissance of various areas that we want to decide, do we really want to drive over or go over and look over there. Send them into areas that perhaps are of such scientific specialty that we don't really want, we really want to make sure we don't contaminate them in any way. So we're going to send something over there to do a special experiment and bring it back so we don't have to take everything over. I think these are really going to expand and change the way we think about doing exploration on other planetary surfaces. So really, really looking forward to this.
Very excited to see that as well, Lori. Okay, let's go back to the media phone bridge now and take a question from Joey Roulette with Reuters. Joey?
Hey, thanks for doing this. I was just wondering, what is the total distance Perseverance will travel in the next 7 months, and how patient will the team at JPL have to be during that time? And I also just wanted to follow up on Marcia's question earlier to Matt. What were the feelings in the room when the teams were working through that comms issue after a long launch day? Were there sweaty palms or any nerves? Thanks.
Dr. Z, why don't you take the trip to Mars? How long is it? The distance?
6.5 months.
What's that?
He wanted it in miles?
Length of time, the miles? Yeah.
Oh, did he ask the distance, I believe?
Oh,
yeah,
the distance.
Distance traversed.
100 million miles,
Yeah.
to travel from here to Mars. And yeah, the team will. They still got plenty of preparation to do for entry, descent, and landing, and surface operations. So they'll be busy during that period of time for sure.
I do want to talk about the second question. It's like, how was it when the team addressed this issue? I just want to tell you, like it always is. This is, you want to be a rocket scientist, this is what you do. It's like, we're not just scoring hole-in-ones every time. And what we do is we let the people work. We had Matt talking to us, and we let him work, and we listened what he had to say. We did not add data. We listened what we had to say. We communicated it like we always do. It's like we always do it. It's just, I mean, you have to have a little bit of nerves if you're in that business. But the point is, that's why we love it so much. It's because we solve problems together as teams. Right now, I know, I do not see them right now, but I feel them. Right now, there are these amazing JPLers sitting there in Pasadena. There's some people right here solving this problem right now. Before I go to bed, I will know what it is in detail. I'll take any bet with anybody who wants that right now. Why do I do that? Because I observe it every time. And, you know, whether that's with JPL, whether that's with Goddard, whether that's with Lockheed Martin, this is the commitment that it takes. And so for me, it was exactly like it always is. It's just an issue. It's rocket science.
Excellent. No takers on that bet here. Let's go back to the phone. And Mary Liz Bender from Inverse, you have a question?
Yes, thank you so much. Wow, that was such a beautiful launch today. Congratulations. I am really excited about all of the new functionality on this rover. I've been talking to the JPL engineers all week about how we keep stepping up the rover status, and now I know we're working toward getting to a place where we can have huge rovers that can assist humans in our exploration of Mars. So I'm just curious, what are kind of the steps that take us from here to there? I'm sure we don't know everything, but what do you kind of see as maybe the next set of missions, and how might they improve on this one?
I can take that one. So I think the next step that's going to move us along towards human exploration that we'd like to see at some point in the decades to come here is the Mars sample return mission. This is the very next mission to Mars that'll follow on after Perseverance, and it's actually the next step in trying to go back to Mars and collect the samples that Perseverance is going to store on the surface for us. And that Mars sample return mission is actually going to demonstrate even more capabilities that we're going to need in order to explore with humans at Mars. First off, that mission is going to have to be able to demonstrate how to launch from the surface of Mars. We're going to send a rocket, the Mars Ascent Vehicle, to Mars. We're going to have to get those samples and put them into that rocket and launch them into orbit at Mars. And we certainly are going to need that capability when we send humans. We're also going to demonstrate with that mission the ability to rendezvous in space around another planet. We're going to, when we launch that sample into orbit around Mars, we're going to have an orbiter there also at Mars, and it will hook up with that sample and capture it into capture and containment system on the orbiter, and then we'll have to deorbit at Mars and return to Earth. And all of those technologies and all of those capabilities are going to be necessary when we send humans. So I think we just, with each mission, with each robotic mission, we demonstrate those next capabilities that we're going to need and build the bridge that we're going to need to get to human exploration.
All right, thank you, Lori. Yes, sir.
And that is that you know, there's three more things that are really important. The first one is that actually, roughly in the same time frame, we're trying to design an ice mapper, one that is really focused on actually finding water resources, because also that we want to have available for humans when we're going. It's part of our budget that's under consideration on the Hill. I think the second thing I want to say for the science community, this is a really interesting decadal that just started, because this decadal has a lot more opportunity focused on the collaboration with human exploration than in the past. And the third piece is, increasingly, as we go to the moon with astronauts, we learn back all these things that in the past perhaps we knew, but in entirely new ways with commercial partners, with international partners. We're also going to learn how to build these capabilities that actually bring, you know, humans to Mars in the late 30s. So for us, that's really, you know, these three things in parallel, over and above the Mars sample return, are just, you know, really opening up the spectrum on Mars exploration to a level which no other decade really has in the past.
All right, thank you, Dr. Z. We have some questions on social media that we're going to get to in just a second, but first let's get a question in from Eric Berger with Ars Technica. Eric?
Hi, congratulations, everyone. Thanks for doing this. Wondering if someone there could clarify whether the spacecraft is currently in safe mode, and if that's normal procedure for this time, and you know when it's going to be brought up to sort of regular operations in deep space. Thank you.
So when we started this discussion, we weren't really sure, but it appears as though we came off the launch vehicle in our normal cruise mode. I'm just getting some indications that we had a minor temperature transient that's recovered that may have put us into safe mode. If so, that's perfectly fine. The spacecraft is happy there. So the team is working through that telemetry. They're going to look through the rest of the spacecraft health. So far, everything I've seen looks good, and so we'll know more in a little bit.
And now to social media. James on Twitter asks, when is the landing date on Mars? We know that to be February 18th, 2021. I think at 3:30 Eastern. Is that something roughly like that? Stay tuned on that one. And then when is Ingenuity's first flight, Lori?
Question. Matt's going to have to give me some help here, but I believe it's about 30 to 60 days after we land.
We're hoping to get it done somewhere in that time frame, maybe 50 to 90 sols. Each day on Mars is called a sol, and so within the first 50 to 90 Mars days or so, we hope to start flying the helicopter.
Very good. Vizag on Twitter asks, how significant will it be to us humans if we find signatures of ancient life or maybe present life on Mars? Dr. Z?
Those are the kind of questions that, frankly, keep me up at night in excitement, not in worries like some other nights like the last one. Because if you look at history, recognitions like that, new insight like this, have transformed not only how we think about ourselves, but frankly, how we think and act as humans, right? The recognition that the sun is the center of the solar system, not the Earth, had tremendous impact on Earth. And so for me, the life question is really quite foundational. I'm really interested in what the administrator says to this, right? For me, it's as a scientist, it's really the holy grail. It's like, when you go from n equals 1, there's only one life we've ever observed, to n equals many, multiple lives, everything changes. You can do research, you can ask questions, you have no clue how to even start, right? It's like opening up a whole new building of exploration in a way you never could. But how do you feel about it?
Well, I think there would be no bigger discovery in the history of humanity than finding life that is not on our own world. And I think it'll fundamentally transform how we do exploration in the future. We've been on this path of following the water to determine if some place is habitable or not. Now we know that there was, at one point in time, habitability on Mars. We don't know if it was inhabited, but if we were to make a discovery that it in fact was, I would imagine everything from that point forward is going to be, okay, what other life is out there? How do we get to it? How do we study it? How do we understand it? It'll be absolutely the biggest discovery, I think, in history. But I also think it will enable us to do more than we've ever been able to do before, because there will be such a profound interest in going further and doing more. So look, I think everybody's going to have to answer that question for themselves. But certainly, there's a lot of interest in finding life that's not on this world, and that's what we're trying to do.
Absolutely, and thank you for that. One more question from social media. Dennis Morissette on Facebook asks, are the cameras on board Perseverance much better than those on Curiosity? And we understand that they are.
They are, yeah. We have a number of different cameras on board. I talked about the what we call the entry, descent, and landing cameras. Those are high definition 1080p type video cameras. We also have a set of science cameras at the top of the mast, which are called Mastcam Z cameras, and they're enhanced from the Curiosity cameras in that they have a zoom capability, and so those are also better. We also have a set of engineering cameras dispersed around the rover. Those engineering cameras we use to look at the surroundings, to look for hazards when we're driving, when we're doing our workspace operations with our robot arm, and those sorts of things. And those are significantly higher resolution than the ones on Curiosity. I think they're on the order of about 20 megapixels color cameras, and Curiosity carried 1 megapixel black and white cameras, just to give you a sense. So, yeah, we've kind of upgraded our cameras across the board on the vehicle. Yeah,
it's going to be like being there. 20 megapixel.
It will be, and we have a just add in. We have a microphone as well. So not only will we be able to see things, but we'll be able to hear them as well for the first time. And so it's going to provide a real presence for us.
That's outstanding. All right, let's go to space.com, and we have a question from Megan Barteef. Go ahead, Megan.
Hi, Megan Bartels from Space.com here. Thanks so much for taking my question. The first part of it is for, I think, Mr. Bridenstine or Dr. Glaze. I was hoping you could talk through sort of how exciting it is to get a planetary science mission like this off the ground in the middle of a pandemic. And then for Mr. Wallace, if you could talk a bit about what the next 7 months look like for the team and any way that that has been shaped or affected by the pandemic as well. Thanks so much.
Sure. I'll start, and then I'll let Lori take it from there. But when we think about this particular mission, when I first came to NASA, it was quite frankly in trouble, and people were worried about whether or not we were going to be able to launch in 2020 at all. And then we made it even more complex by saying, hey, we want to put a helicopter on here as well. We gave it the resources, we gave it the attention. JPL did a magnificent job. At one point we had a cracked heat shield, and of course Lockheed Martin and our partners there moved forward to get that fixed. So yes, adversity all along the way, but this is true for any project of this nature. But you know what? What we didn't expect was something that is, as you identified, the pandemic. And so you add all of the adversity in a project like this together, and then you put on top of that the coronavirus, and people, like a large fraction of NASA's workforce and JPL's workforce and the ULA workforce actually staying at home, and the other part, smaller parts of our organizations going to work with personal protective equipment, socially distanced, breaking up the shifts so that we can minimize the amount of contact. I'm not going to lie, it's a challenge. It's very stressful. But look, the teams made it happen, and I will tell you, I know Tori Bruno said it earlier, we could not be more proud of what this integrated team was able to pull off here. So yes, it's very, very exciting. Lori?
And I'll just echo some of what Jim just said there. Our teams across the board, this is, within NASA, at NASA headquarters, at multiple centers across the country, NASA centers across the country, at JPL, all came together to try and make sure that we got Mars 2020 to the launch pad today. It was truly a team effort, and in every single case, everyone stood up and said, yes, we want to do what we can to help. Whether it was providing aircraft to transport personnel, or whether it was, trying to make sure that we had the right protective equipment, that we were providing the support that the teams needed to come in to work if they were needed to put hands on hardware. But it was not easy, and as Jim says, a lot of our workforce has been working from home and trying to balance the work that had to get done with sharing the Wi-Fi bandwidth with their spouses, who are also trying to get their work done, and their kids are trying to do their school work and get their work done. It's been a real challenge, and I have to say that I think all of us within the Planetary Science Division are so excited and so happy that we were able to pull this off, to actually get it done. It was a lot of work, but I'm proud of my team. I'm proud of the JPL team. I'm proud of every one of them. We somehow made it through this.
All right, we'll get a question in from Keith Cowing with NASA Watch. Keith?
Thanks for giving us this opportunity today. Right now, the nation's in the midst of a pandemic nightmare, and it's not going to end anytime soon. It's going to be a dark, scary winter with 328 million Americans going to be staring at their computers and their TVs, as will billions of people around the world. NASA's sending an astrobiology droid to Mars to look for evidence of life. It may discover that we're not alone. Now, how cool is that? It's been nearly half a century since the Viking landers attempted much the same task. Now, the world could use some good news right now. How is NASA going to involve the world in a way that speaks to the way that we're all isolated yet still connected? In essence, how will NASA make the Perseverance mission a bright light amidst an otherwise very gloomy winter?
No, that's an important question. I think the key word that you use there is the word astrobiology. I don't even know if maybe 10 years ago we even used that word, but now it's very apparent that we have water throughout our own solar system, and there are places in our own solar system that could in fact be habitable not just in the ancient past, but even today. And so yeah, I think that putting together these kinds of missions that could not just inspire the next generations, but inspire those of us that are in the middle of our career or maybe even retired. These are the kind of things that NASA can do in very difficult times, and we're excited about it.
And we have a follow-up to that from Dr. Z.
I really appreciate that question, Keith. And you talked about this as a bright light. I believe that so much, and I think from the beginning, the administrator and I talked about it just that in those words pretty much. And it's great to hear it from you also. You talked about how we're communicating with so many people, and I think the one thing we share here, and I know I speak for my friends on this panel, is that we really want to aspire to open up the communication in a more broad fashion to more people, to talk about the excitement of STEM research, the excitement of space research, the opportunities that come from that. It's exciting, and it's also good for the world. And so for us, the way we're doing that, of course, is as we innovate new missions, we try to innovate new communications. And I just want to tell you, one of the things that made me very proud today is the communication efforts that were set up during the entire week. This team at headquarters, led by Jim and his core group, Paul, one of your people there, I think did just an amazing job really telling the story more broadly. Really, yes, it's a launch, but it's the bright light we're talking about. Yes, it's a mission, but we're talking about transformative science and transformative exploration that goes beyond robotic exploration. And we think of this as a constant challenge, just like the missions need to be reinvented as we go, because we want to do new things. We also need to reinvent communication. I think the social media efforts that NASA has are second to none, but we should not sit still. We always want to go beyond that. We want to go to schools that have not heard that, because in that schoolroom, perhaps in a place where none of us has ever been, is that kid whose life are changing because she sees for the first time that she too could be part of this amazing thing, or something that's exciting to her, which is just as big. So I really appreciate the question, Keith. Yes, it's exciting what we're doing here, but the communication and how we talk about it is also really relevant. And I think we understand that, and we also recognize that we need to, as we go forward, learn and evolve.
And that was well communicated as well. Thank you, Dr. Z. The toughest question, we're going to slip one more in. We only have a few minutes left. Probably is the toughest. We'll let Jim decide, because it's going to you. Facebook, Eva asks, when do you project astronauts will arrive on Mars?
Well, I think it could definitely be technologically, it could be the mid-2030s. The risk here is not the technology and not the amazing teams that we have at NASA and with our commercial partners and international partners. The challenge is and always has been political. To do these kinds of missions requires budgets. I will tell you this, the President's budget request right now that is being considered by the House and the Senate is the highest budget that NASA has ever had in nominal dollars. The current budget that we have is the highest budget that we've ever had in nominal dollars, and next year it's going up even higher. And that's with bipartisan support in the House and the Senate. We have gotten the budget that we have, and of course next year we want to get even more. And we need more because we need to go to the moon sustainably to prove that we can live and work on another world for long periods of time. And we go to the moon because it's always a 3-day journey home. And we can prove what we need to prove there so that we can eventually send humans to Mars. We've got the robotic precursor missions, which we've been talking about today, but we also have human precursor missions at the moon. We love Apollo. The challenge with Apollo is that it ended. And now we're going back to the moon with commercial partners and international partners under the Artemis program, learning how to use the resources of another world, in this case the moon, so we can apply all of that for our eventual long-duration mission to Mars. We can do it. And of course it's going to require financial support. The House and the Senate are considering the budget right now. And I would just extend a request that when they think about these things, for the budget request, think about what happened today. Think about what's going to happen in February when we land on Mars again, this time with an astrobiology mission and a helicopter and an ability to convert carbon dioxide into oxygen. Think about what we just did with launching American astronauts on American rockets for the first time since 9 years ago, 2011, the retirement of the space shuttles. Look, we can do these things. They require resources. They require the American public to believe in what we're doing. And of course, it requires mission success. And I will tell you, this team has proven that they can successfully accomplish these missions. If we were to receive the budgets, I'm very confident that we could get there by the mid-2030s.
All right, and we will close on that note. We appreciate all of you being here. Our special guests today, we know you woke up early, so thanks for sticking around and participating in this post-launch news conference. And thank you to all of our social media participants as well as members of the media. For more information on today's mission, you can go to nasa.gov, nasa.gov/perseverance, and mars.nasa.gov/perseverance. Thank you for joining us, everyone. Have a great day, and remember, keep looking up.
Chelsea Walker. I'm a materials and process design engineer for Northrop Grumman, the lead contractor for the solid rocket boosters of NASA's Space Launch System. This is rocket science in 60 seconds. These boosters produce 7.2 million pounds of thrust during liftoff and flight. I work on the insulation that protects the SLS solid rocket booster during flight. Here, in the Insulation and Component Work Center, the insulation, a rubber-based material, is applied to the inside of the rocket motor case